Resort Batu. Before you do your business, before you do your meeting room, before you do your meeting today, let me explain to you a little bit about safety induction at our ballroom. Before that, let me explain myself. My name is Sigit. I'm from security. Now we are at Golden One Ballrooms. In this ballroom, we have fire exhausting, smoke detector, fire detector, and we have two emergency door too behind of us and on the right side, so you can use for when the emergency stage. In this ballroom too, close with the reception office. So if you need something or helps, we are ready. We have from security for help you to guide you to the assembly point if emergency stage. Well, maybe that's all that I can talk to you, to explain to you. Enjoy your meetings. God bless you. Thank you.
Good morning, everyone. Thank you so much for being here. And let me begin by giving you a warm welcome to the second ICO AMIS International Conference on Engineering and Management in Industrial System by Industrial Engineering Department, Universitas Brawijaya.
So please register at the registration desk beside the door before going inside. And during the situation, to ensure the smoothness of our program, please, I ask all of you to wear masks so we can feel safe during the event.
And also, we are so thankful this event too, organized by Industrial Engineering Department, Faculty of Engineering, Universitas Brawijaya,
Co-organized by University Technical Malaysia, Melaka,
and supported by BKSTI and PEI.
And our sponsor, BRI Bank Rakyat Indonesia,
PJB, PT Pembangkitan Jawa Bali,
PT Medco Energi Internasional,
dan BSI, Bank Syariah Indonesia, for supporting the second ICO AMIS.
And now our operator will assign for all Zoom participants. For all Zoom participants, good morning. Thank you so much for being here. Let me give you a warm welcome to the second ICO AMIS. Ladies and gentlemen, the opening ceremony is going to start in 5 minutes. For all participants here, please be seated. And for all participants in Zoom meeting, please stand by, turn on your camera, and don't forget to use virtual background.
And we will play the
video profile of Industrial Engineering Department, Universitas Brawijaya.
Terletak di dataran tinggi di Pulau Jawa, Kota Malang terkenal sebagai kota pendidikan dengan cuaca yang sejuk sepanjang tahun, wisata alam yang menakjubkan, dan bangunan bersejarah yang ikonik. Pada tahun 2005 di Kota Malang, telah lahir Departemen Teknik Industri sebagai jawaban akan kebutuhan dan tantangan masyarakat industri menyongsong Indonesia maju. Mendorong peran aktif mahasiswa Departemen Teknik Industri untuk berkontribusi nyata dalam penyelesaian persoalan bangsa melalui kerangka Tridharma Perguruan Tinggi. Mahasiswa dibekali karakter yang kuat dengan mengutamakan keimanan, berbudaya, integritas, mampu berwirausaha, dan mampu berprestasi.
Departemen Teknik Industri berkomitmen melaksanakan visi dan misi Universitas Brawijaya dengan sungguh-sungguh menuju departemen bertaraf internasional, melaksanakan Tridharma Perguruan Tinggi baik melalui penelitian, pendidikan, dan pengabdian kepada masyarakat yang berbasis pada kearifan lokal. membangun karakter mahasiswa yang bertakwa, berbudaya, berintegritas, dan mampu berwirausaha serta mampu berprestasi. Salam satu visi Jaya TI.
Untuk menjamin terciptanya harmonisasi antar unit kerja, antara pencapaian kinerja yang optimal dan rekognisi di tingkat nasional maupun internasional. Sesuai dengan standar nasional pendidikan tinggi, kami selalu memastikan tercapainya kualitas pendidikan yang sangat baik melalui target akreditasi nasional dan internasional. Saat ini, program Sarjana Teknik Industri telah terakreditasi unggul oleh BAN PT. Setiap tahun, Departemen Teknik Industri menerima sekitar 200 mahasiswa yang akan mengembangkan keilmuan di 6 kompartemen, yaitu Quality and Reliability Engineering, Manufacturing System, Industrial Optimization and Information System, Ergonomic and Work System Design, Logistic and Supply Chain Management, dan Business Engineering and Industrial Management. Layanan prima dan inovasi berkelanjutan menjadi nafas kami dalam menjalankan tugas kesehariannya. Tridharma Perguruan Tinggi yang diterjemahkan dalam Indikator Kinerja Utama atau IKU dilaksanakan dengan seoptimal mungkin. Hal ini terbukti dengan terselenggaranya pendidikan yang berbasis pada Outcome Based Education atau OBE, penelitian dalam berbagai keilmuan teknik industri, dan pengabdian pada masyarakat yang berbasis kearifan lokal. Departemen Teknik Industri didukung oleh pendidik dan staf pendukung yang sangat kompeten dan profesional. Kami memiliki tenaga pendidik 37 dosen dari lulusan berbagai universitas ternama baik dalam negeri dan luar negeri, 6 kompartemen pengembangan bidang keilmuan, 6 laboratorium, dan 1 studio. Ada 6 laboratorium dan 1 studio yang bernaung di bawah Departemen Teknik Industri, yaitu Laboratorium Analisis Data dan Rekayasa Kualitas, Laboratorium Ergonomi, Perancangan Kerja, dan Inovasi Produk, Laboratorium Optimasi, Sistem Informasi, dan Pendukung Keputusan, Laboratorium Sistem Manufaktur Ramping dan Berkelanjutan, Laboratorium Rekayasa Bisnis dan Rantai Pasok, Laboratorium Ilmu Keteknikan Dasar, Studio Proyek Perancangan dan Tugas Akhir, Himpunan Mahasiswa Teknik Industri berkedudukan sebagai wadah kemahasiswaan yang merupakan kelengkapan jurusan dan menyelenggarakan kegiatan ekstrakurikuler dan kokurikuler yang bersifat penalaran sesuai dengan program studi jurusan serta melakukan advokasi kepada mahasiswa yang menemui masalah akademis dan kemahasiswaan. Departemen Teknik Industri menyediakan fasilitas-fasilitas untuk mendukung suasana akademik yang meliputi ruang kelas yang memadai, ruang diskusi yang nyaman, laboratorium, perpustakaan, ruang baca, sarana ibadah, auditorium, ruang recording, kantin, dan pusat kegiatan mahasiswa. Departemen Teknik Industri dipercaya akan semakin berkembang melalui kerjasama dengan berbagai stakeholder. Program pertukaran pelajar, double degree, program visiting professor, kolaborasi research, dan kolaborasi konferensi internasional. Departemen Teknik Industri mendorong seluruh sivitas akademika untuk mendapatkan prestasi baik di bidang akademik maupun non-akademik. Prestasi dosen berupa paten atas inovasi penelitian meningkat setiap tahunnya. para mahasiswa juga memperoleh prestasi yang membanggakan di tingkat nasional maupun internasional. Dengan semangat inovasi dan kolaborasi, Departemen Teknik Industri akan bekerja keras memberikan prestasi terbaik untuk pembangunan berkelanjutan Negara Kesatuan Republik Indonesia. Mahasiswa Departemen Teknik Industri memiliki kemampuan rekayasa teknik dan manajemen di bidang industri, baik industri manufaktur dan jasa. Selain itu, mahasiswa juga dibekali dengan kemampuan untuk bekerja dalam tim, mengambil keputusan dengan tepat, berinovasi, dan berwawasan global. Lulusan teknik industri dibekali diri untuk mampu berwirausaha dan bekerja di berbagai bidang keilmuan teknik industri, seperti di perusahaan, bank, lembaga pemerintah, lembaga riset, dan lain sebagainya. Lulusan Departemen Teknik Industri memiliki jiwa yang beriman, berbudaya, berintegritas, mampu berwirausaha, dan mampu berprestasi baik nasional dan internasional. Kunjungi kami di industri.ub.ac.id dan kontak email kami industri@ub.ac.id.
Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan.
The Honorable Dean of Faculty of Engineering Universitas Brawijaya, Profesor Hadi Suyono, PhD ASEAN Engineer, the Honorable Vice of Dean of Student Affairs, Alumni, and Student Entrepreneurship, Doctor of Engineering Insinyur Heri Santosa, STMT IPM,
The Honorable, our keynote speaker, Professor Ian Campbell, Professor Benjamin McClellan, Associate Professor Dr. Zuhria binti Ibrahim,
Professor Yasirli, PhD SPE, Professor Berta Maya Sopa, PhD, and Professor Ishardita Pamuditama, PhD, and the Honorable ladies and gentlemen here.
Good morning, and we are delighted to welcome you for Golden Tulip Hotel, Malang, Indonesia, for the second ICO International Conference on Engineering and Management in Industrial System, organized by Industrial Engineering Department, Faculty of Engineering, Universitas Brawijaya.
First of all, let's say thanks to God who give us guidance, happiness, healthy, and mercy so we can attend and participate on this special event without any obstacles. So, the second ICOMIS 2022 is a scientific event for research, engineers, academicians, as well as industrial professionals from all over the world to present their ideas, research results, and development activities in terms of industrial system engineering and management. It's a precious chance for me, Camila, and my partner,
Dava,
to be your master of ceremony and this very special occasion. It's a special day for us because we can meet again with all participants after a long hard time by this hybrid event.
Ladies and gentlemen, before we come to the main session, let us start this by praying first. So, the event that we will hold on this day will run well without any obstacle at all. Pray based on individual belief. Begin. And done.
Ladies and gentlemen, on this nice occasion, let me deliver the structure of the event today as follows. The first is opening, singing national anthem, speech, Indonesian traditional dance performance, keynote speech, parallelization, awarding, and closing ceremony.
Ladies and gentlemen, please remain standing for the singing of the national anthem, Indonesia Raya. Thank you very much, ladies and gentlemen. Please be seated.
Well, move on to the next agenda is the opening speech from Dr. Wida Kusumaningdia as a conference chair of the second ICO EMIS. To Dr. Wida Kusumaningdia, time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, may peace, mercy, and blessings of Allah be upon us. Good morning. First of all, I am pleased to welcome the Honorary Dean of Faculty of Engineering, Professor Hadi Suyono, and the Honorary Vice Deans, Dr. Heri Santosa, and also our honorary guests, heads of department from Engineering Faculty, Dr. Oyong Novareza, and also I am excited to welcome our keynote speakers today, Professor Ian Campbell from Loughborough University, UK, and also Professor Ben McClellan from Kyoto University, and Professor Yasili from Bandung Institute of Technology. Assalamualaikum, Bapak. Professor Zuhria Binti Ibrahim from Technical University of Malaysia, Malacca. Professor Berta Mayasova from University of Gadjah Mada. Assalamualaikum, Ibu. And also Professor Isharida Pambuditama from Universitas of Brawijaya. Assalamualaikum, Bapak. And I would also warmly welcome everyone to the second International Conference on Engineering and Management in Industrial System, the second ICO-EMIS. And thank you for being here with us in Malang, for participating and for lending your expertise on this important topic. And with the record number of participants expected this year, we are delighted to see that this biennial conference is becoming larger and more substantial every year. And to open the conference, I will give a brief tour of our presenters on display. To begin with, there were 134 abstracts of paper registered on the system to be reviewed, and eventually we have 88 papers accepted to be presented today online and on-site. And our presenters come from countries including Japan, Taiwan, Korea, Thailand, Timor-Leste, and also Indonesia, and covering scholars and researchers from 44 universities and companies. And from Indonesia alone, we have presenters from across universities and companies from Papua, Sumatra, Bali, and Java. And in closing, I then express my sincere gratitude for the willingness of all attendees, keynote speakers, and all organizing committees for the maximum effort that has been made to obtain the selection of relevant papers with better innovations, creativity, and scientific contributions. Finally, this event is hopefully able to provide inspirations of better and more optimal researchers for the success and prosperity of all mankind from the developed science and technology. And we wish you success in this conference, and may you feel happy, and comfortable during your stay here in Batu, Malang, Indonesia. Thank you.
Thank you, Dr. Wida Kusumaningdia, for the speech.
Okay, before that, we said welcome to Vice Dean for Academic Affairs, Doctor of Engineering, Indradi Wijatmiko, and welcome Vice Dean of General Financial and HH Affairs, Insinyur Ismurini Dwi Ari, PhD.
Moving right along, we are welcoming our Dean of Faculty of Engineering, Universitas Brawijaya, Professor Hadi Suyono, PhD, ASEAN Engineer, to deliver opening speech and officially open the second ICO-EMIS. Before that, we are sorry for the Dean can't join with us here, but he sent this greetings video for us, and we will play the greetings speech for our Dean.
Assalamualaikum warahmatullahi wabarakatuh. In the name of Allah, the most beneficent and most merciful. May peace, mercy, and blessing of Allah be upon you all. Dear colleagues, professors, lecturers, researchers, ladies and gentlemen. On behalf of Faculty of Engineering, Universitas Brawijaya, I would like to express my sincere gratitude and welcome you to the second International Conference on Engineering and Management in Industrial System, e-commerce in Batu, Malang, Indonesia. With a record number of participants expected this year, we are delighted to see that this biennial conference is becoming larger and more substantial every year. Moreover, I honorably welcome to our keynote speakers, Professor Ian Campbell from Loughborough University, UK, Professor Benjamin McClellan from Kyoto University, Japan, Professor Yasirli from Institute of Technology Bandung, Indonesia, Dr. Sungria Ibrahim from University Technical Malaysia, Malacca, Malaysia, Dr. Berta Maya Sopa from University Gajah Mada, Indonesia, and Dr. Ishardita Pambunitama from Universitas Brawijaya, Indonesia. It is my hope that the second e-commerce 2022 would be able to achieve its objective in providing an effective forum for academicians, researchers, and practitioners to advancing knowledge, research, and technology for humanity. The theme for this year's conference is Building Sustainable Industrial System for Resilient Society Post-Pandemic, which is particularly appropriate for a meeting at this moment. The pandemic brought challenges for industries to sustain their best business as usual and affected the society's struggle to live normally. During this period, social and economic behavior is changing, energy transition is expanding, and technological disruption is occurring, forcing industries to continually adapt. Therefore, I am excited about the wide variety of ideas that scholars and practitioners will bring into our fold. This richness of ideas bodes well for our future sustainable industrial system to achieve resilient society. This year's conference is held on hybrid mode. It would not be possible without generous help from a large number of people. I am truly grateful to the conference organizing committee members, the track chairs, the paper's reviewers, the session chairs, and the numerous volunteers for generous contribution to this conference. We also appreciate the contribution of numerous sponsors supporting this conference. Most of all, thank you, the participants, for enriching this annual conference by your presence. I hope you will enjoy the contents, renew old friendships, make new friends, get new ideas, and above all, have a good time. May God Almighty guide us all in carrying out our respective role and realizing our contribution in society. Thank you very much for your kind attention. Wassalamualaikum warahmatullahi wabarakatuh.
Traditional dance, Tari Gading Alit. So Gading Alit dance describe the beauty, the joy, and the agility of Malang district girls. So, give applause to
Sanggar Seni Jakarta. It's such a beautiful dancing. It's such a beautiful song that Sanggar Seni Liswa Jagadita performing to us today. Thank you for a perfect performance from Sanggar Seni Liswa Jagadita. And they also have a title, Malang Youth Ambassador 2021. Give applause to Sanggar Seni Liswa Jagadita again. Okay, the next session is a photo session. For all the participants, please come on, join us to the stage for a photo session and the dancer too. Okay, for all the Zoom participants, please turn on your video camera and don't forget to use our virtual background.
We're still waiting for Zoom participant to turn on your camera.
And don't forget to say cheese too, ya.
Okay, we're still waiting for Zoom participant for turn on your camera.
And don't forget using our virtual background.
And get prepared with the best pose and best smile.
Of course. For all Zoom participants, please turn on your camera and using our virtual background and give your best pose. Okay. And we will counting for a photo session from 1, 2, 3, action. One again. Yeah. Please give your best style. Okay.
You can Okay, thank you very much
for the photo session.
Okay, thank you for all participants for photo session. So the next is for all participants, please enjoy the coffee break that we provided in the dining section for 10 minutes. And the next keynote speaker session will start promptly after the coffee break.
Okay, for all the ladies and gentlemen in on-site who wants to take a picture and can come to the photo booth outside the bedroom.
And also, we are so thankful this event organized by Industrial Engineering Department, Faculty of Engineering, Universitas Brawijaya,
co-organized by University Technical Malaysia Melaka,
and support by BKSTI and PEI,
and our sponsor BRI, Bank Rakyat Indonesia,
PJB, PT Pembangkitan Jawa Bali,
PT Medco Energi International,
and BSI, Bank Syariah Indonesia, for supporting the second ICO
Amis.
Once again, for all participants here, please enjoy the coffee break that we provided in the dinner section for 10 minutes.
And for all who want to take a picture, can come to the photo booth outside the ballroom. Okay, enjoy your meal at coffee break.
Terletak di dataran tinggi di Pulau Jawa, Kota Malang terkenal sebagai kota pendidikan dengan cuaca yang sejuk sepanjang tahun, wisata alam yang menakjubkan, dan bangunan bersejarah yang ikonik. Pada tahun 1963 di Kota Malang diresmikan Universitas Brawijaya dan menjadi salah satu perguruan tinggi terkemuka di Indonesia. Sebagai himpunan sumber daya pendukung yang menyelenggarakan dan mengelola pendidikan akademik dan atau pendidikan profesi dalam satu rumpun disiplin ilmu pengetahuan dan teknologi di Universitas Brawijaya, Fakultas Teknik berperan penting dalam memajukan bidang keteknikan melalui pendidikan, penelitian, dan pengabdian masyarakat.
Menghadapi dinamika pengelolaan pendidikan tinggi di masa depan yang semakin meningkat, Fakultas Teknik Universitas Brawijaya siap menghadapi tantangan untuk mencapai tujuan pada era industri 4.0 dan era society 5.0 dengan mengedepankan semangat kerja, tuntas dan berintegritas. Fakultas Teknik Universitas Brawijaya juga fokus pada penyelenggaraan sistem pendidikan yang inovatif dan aplikatif untuk meningkatkan daya saing mahasiswa dan menghasilkan lulusan yang unggul dan berkompeten. Pencapaian prestasi dan peningkatan reputasi juga dilakukan melalui kolaborasi dan sinergi. Kegiatan penelitian dan pengabdian kepada masyarakat menjadikan Fakultas Teknik yang inovatif, kolaboratif, dan berdaya saing internasional. Sejalan dengan profesionalisme dan integritas, Fakultas Teknik Universitas Brawijaya akan terus berkontribusi bagi kemajuan masyarakat dan pembangunan nasional Negara Kesatuan Republik Indonesia. Together, we do the best.
Untuk menjamin terlaksananya harmonisasi antar unit kerja, pencapaian kinerja yang optimal dan rekognisi di tingkat nasional maupun internasional, Fakultas Teknik senantiasa melaksanakan sistem penjaminan mutu internal yang meliputi penetapan, pelaksanaan, evaluasi, pengendalian, dan peningkatan program-program kami secara berkesinambungan. Sesuai dengan standar nasional pendidikan tinggi, kami selalu memastikan tercapainya kualitas pendidikan yang sangat baik melalui target akreditasi nasional dan internasional. Seluruh program sarjana kami telah terakreditasi unggul atau A oleh BAN PT atau LAM Teknik. 2 program studi telah tersertifikasi terakreditasi internasional dari AUN-QA dan IAB. Setiap tahun, Fakultas Teknik menerima sekitar 1.300 mahasiswa yang akan menuntut ilmu pada 8 program sarjana, 7 program magister, 4 program doktor, dan 1 program profesi. Kami memiliki 18 guru besar aktif, 132 doktor, dan 272 dosen dengan reputasi unggul pada penelitian dan publikasi ilmiah. Terdapat juga 63 laboratorium untuk mendukung kegiatan pendidikan dan penelitian oleh dosen maupun mahasiswa. Fakultas Teknik berkomitmen untuk terus meningkatkan kompetensi dosen dan mahasiswa, terutama menghadapi era digitalisasi. Sembilan departemen yang bernaung di bawah Fakultas Teknik adalah Departemen Teknik Sipil, Departemen Teknik Mesin, Departemen Teknik Pengairan, Departemen Teknik Elektro, Departemen Arsitektur, Departemen Perencanaan Wilayah dan Kota, Departemen Teknik Industri, Departemen Teknik Kimia, Program Studi Program Profesi Insinyur, Program Magister di Fakultas Teknik, Teknik Sipil, Teknik Mesin, Teknik Pengairan, Teknik Elektro, Arsitektur Lingkungan Binaan, Perencanaan Wilayah dan Kota, Teknik Industri. Program Doktor di Fakultas Teknik, Ilmu Teknik Sipil, Ilmu Teknik Mesin, Teknik Sumber Daya Air, Teknik Elektro. Fakultas Teknik banyak menyediakan fasilitas-fasilitas untuk mendukung suasana akademik yang meliputi ruang kelas yang memadai, ruang diskusi yang nyaman, laboratorium, perpustakaan, tempat ibadah, kantin, pusat olahraga, dan pusat kegiatan mahasiswa. Fakultas Teknik mempunyai BEM, Badan Eksekutif Mahasiswa, Himpunan Mahasiswa, Departemen dan lembaga semi-otonom sebagai wadah untuk melaksanakan kegiatan kokurikuler dan ekstrakurikuler mahasiswa, terutama dalam bidang minat, bakat, dan kesejahteraan mahasiswa sesuai dengan aspirasi mahasiswa yang disalurkan melalui organisasi yang ada. Fakultas Teknik dipercaya akan semakin berkembang melalui kerjasama dengan berbagai stakeholder. Program pertukaran pelajar, double degree, program visiting profesor, kolaborasi riset, dan kolaborasi konferensi internasional. Fakultas Teknik mendorong seluruh sivitas akademika untuk mendapatkan prestasi yang baik di bidang akademik maupun non-akademik. Prestasi dosen berupa paten atas inovasi penelitian meningkat setiap tahunnya. Para mahasiswa juga memperoleh prestasi yang membanggakan di tingkat nasional maupun internasional dengan semangat inovasi dan kolaborasi. Lulusan Fakultas Teknik Profesional, tangguh, siap membangun negeri dan meningkatkan kesejahteraan masyarakat. Fakultas Teknik Universitas Brawijaya akan bekerja keras memberikan prestasi terbaik untuk pembangunan berkelanjutan Negara Kesatuan Republik Indonesia.
Satu, dua, tiga, teknik.
Kunjungi kami di teknik.ub.ac.id.
Okay, thank you. Ladies and gentlemen, the main session is going to start. Please be seated. Once again, I'm sorry, ladies and gentlemen, the main session is going to start. Please be seated.
Okay, ladies and gentlemen, move on to the main agenda is keynote speech from Professor Ishardita Pambuditama, PhD, from Universitas Brawijaya.
So, Professor Ishardita Pambuditama, PhD, is an expertise on manufacturing management and research on Industry 4.0.
And ladies and gentlemen, please join me to welcoming Professor Ishardita Pambuditama.
This is the first picture. And this is the second one. This is the third one. Some of you may know already what kind of car is this. Okay. So the first one is Tesla Model Y. This is the best selling EV in the world currently. And the second one is the Wuling Mini EV, currently the second best selling electric vehicle in the world. And this one is also Wuling. This is a Wuling Air EV, the best selling electric vehicle in Indonesia right now. So if you see those pictures, what do you have in mind? Some of you might think about electric vehicle is the solution for the cheaper, for the cleaner, more sustainable solution for transportation. However, at least for now, currently, I beg you to differ. Electric vehicle is not the cheaper, it's not the cleaner, it's not sustainable for our environment. But just hold on before you throw me out from the stage. Let me explain it to you, okay? So if you want to propose better system for the transportation, in this case, electric vehicle, we cannot just see the electric vehicle from one system, but we have to see it from the whole ecosystem. So we have to apply the system thinking to analyze the sustainability of the electric vehicle. And in our research, we use system dynamics simulation to combine all of the factors that affect the implementation of electric vehicle, especially in Indonesia. So if we talk about the supply chain of electric vehicle, we have three main stages. The first one is the upstream. The second one is the midstream, and the last one is the downstream. We can see here that the entire supply chain system of electric vehicles, starting from the raw material mining, and then battery cell manufacturing, and then battery pack assembling, all the way to the use of the consumer, and then recycling the component. For the first stage in the upstream, the process is the raw materials production, and the electric vehicle is mainly, the cost of the whole electric vehicle dominated by 50% the price of the battery pack. So analyzing the process of manufacturing of battery pack is very important. Currently, the EV battery is dominated by lithium-ion technology battery, which mainly consists of lithium and cobalt, and also nickel. Lithium and cobalt is mainly supplied from Chile and Congo, which in Congo, 70% of the raw material or cobalt mining is owned by Chinese company. And fortunately in Indonesia, we have a lot of nickel deposit. Almost 30% of the whole supply of nickel coming from Indonesia. So almost 30% is coming from Indonesia as the biggest, currently the biggest producer of nickel in the world. But one of the biggest concerns about the environmental impact of nickel mining, nickel mining produce a waste called tailing. It's like a mud, but it is very toxic. It is very hazardous to the environment. And almost all of the tailing process using this deep sea tailing disposal, meaning that the tailing produced as a waste from nickel mining is simply thrown to the sea without any process. And almost all nickel mining is using this process. So the DSTD actually has the very big chance to threaten the biodiversity. So even though the sea, we throw it, the tailing into the deep sea, but there is a chance that it's going to affect the whole biodiversity in the ocean. And we also realized that almost all of the raw materials in the battery pack industries is coming from the materials that it's not renewable, it's non-renewable. And then going to the midstream, we have battery cell manufacturing. We have 3 major manufacturers in the world that supply the battery for electric vehicle. The first one is CATL from China, holding 31% of the market share. And then LG from Korea, holding 22% of the market share. And then the third one is Panasonic from Japan, holding 14% of the market share. Meanwhile, in Indonesia, Indonesian government is planned to have a base for the battery pack manufacturing in the world. So they established a consortium which aim to produce 140 gigawatt hours, which includes CATL and LG as the member of the consortium. And then to predict, to forecast how much the increase of the EV sales, we can also look at the price of the battery pack. So we have the data here. In 2010, the battery pack price is quite expensive still, which reached about $1,200 per kilowatt hours. And then it drops significantly in 2020 to $140 per kilowatt hours. And then last year, 2021, it drops to $132 per kilowatt hours. And this year, in 2022, it's slightly more expensive thanks to the Ukraine and Russia war. Now we have around $135 per kilowatt hours. But experts predict that if the price of the battery pack can reach less than $100 per kilowatt hours, that would be the tipping point for the price of battery pack, meaning that the price of the electric vehicle will be much competitive compared to the internal combustion vehicle. And we should also realize that to synthesize the materials to make the battery pack heat between 800 to 1000 degrees Celsius is needed. And that temperature is only cost effectively be reached only by burning fossil fuels. So the manufacturing of battery cell is actually adds CO2 to the environment. And going to the downstream, the manufacturing of EV, as I said earlier, that up to 50% of the EV production cost is coming from the battery itself. And currently we have top manufacturers of EV in the world. The first one is Tesla by value, because you know the price of the Tesla cars is very cheap, very cheap in quote by quote. And then followed by BYD. BYD is coming from China, and they sell more unit of EV compared to the Tesla. Wuling is also coming from the BYD. Meanwhile, in Indonesia, Hyundai already established a plan to produce electric vehicle with the aim of 250,000 units annually. And in the states of the manufacturing of EV itself, we can compare to the ICEV or internal combustion engine vehicle. The ICEV releases about 7 to 10 tons of CO2, while the production of EV releases more, far more than the ICEV, which is reach 19 tons of CO2 to the environment. And for the next stage, the number of EV sales in the whole simulation, especially in system dynamics, we want to predict how many cars will be sold in the future. So we have to analyze based on the factors that determine people to buy those electric vehicles. The first one is the price. Yeah. So currently, the average price of the EV in Indonesia is more than 500 million rupiah, which is not cheap. But if the manufacturers can deliver more EV with the price around 300 million rupiah, that will be the breaking point. That will be the tipping point when people choose EV compared to the internal combustion engine vehicle. The second one is incentive and subsidy. Currently, the government of Indonesia already exempt the import duty, but the tax is still there, and it's quite expensive. But they have a plan in the future that the government wants to switch the subsidy for the fuel to the price of electric vehicle. So once this happens, we can see that more people would buy the electric vehicle. And then the third one, this is maybe the second main reason to buy the EV, is the mileage. Yeah, the mileage price. So based on the data for ICEV, internal combustion engine vehicle, it costs 1,200 rupiah per kilometer. Meanwhile, for the electric vehicle, it costs only below 200 rupiah, not 1,000, but rupiah. So it's very cheap compared to the ICEV. So this would be the second main reason people to buy the electric vehicle. And then for the range, some people delay their decision to buy the electric vehicle because of this, because most of the EV unit available on the market right now, they have maximum of 350 kilometers every single charge. So if we want to go to, like Pak Yasirli wants to go back to Bandung from Malang, he has to spend at least a night in Central Java, somewhere near Central Java to charge it fully. And then the next reason is the number of public charging stations. Currently, we have almost 400 units in September, but we expect to have 25,000 units of public charging station in 2030. And then maintenance cost is also the reason to buy the electric vehicle. The electric vehicle actually have the lower annual maintenance cost compared to the ICEV, mainly because the parts in electric vehicle is far less than the ICEV. So the maintenance is, we can expect it to be cheaper. And then environmental awareness. Some people would buy EV for the awareness for the environment, and then social influence, of course. But still, people who bought electric vehicle now is classified as early adopters still. So not much. And then the last one, this is especially for Indonesia. We think that the resale value is very important. So we have the data that within 3 years, the EV depreciates almost 52%, while IC EV still depreciates less than 40%. So this one is also a reason. Sorry, the last one. So in the use of electric vehicle, of course, we have no gas coming out from the engine, so no tailpipe emissions. So it's very clean. So how about the effect of the increase in EV numbers, especially in Indonesia? The first one, the effects is of course coming from the electricity itself. However, in Indonesia right now, we have the surplus of electricity supply because government already established more power plant, but because of the pandemic situation in the last 2 years, the demand of the electricity is not as high as the government predict. So we can see that government was planned to have the electric stove conversion. Yeah, so because of this, so we have a lot of electricity supplies surplus up to 6 to 7 gigawatt. And then for the generation of the electricity itself, we can see that almost 70% of electricity in Indonesia is generated from coal-fired power plants. So coal is very cheap, very easy to handle. So this is the first choice to generate electricity. However, unfortunately, every coal burning process, we produce coal waste, which is known to be highly toxic to the environment because it contains chemical compounds such as arsenic, lead, mercury, and chromium. And also, coal-fired power plants also produce emissions known as PM 2.5, which can cause respiratory infections. And then the third one that we have to consider is the battery. So every battery waste contains very toxic and hazardous material such as lead, which if we throw it to the dumping facility, it can possibly threaten the water or the soil. So we need to have the recycling facility. That's very obvious. So in our research, we made a model so we can incorporate all of the factors from the cause to the effect into one model and simulate it. However, it is still in progress. I cannot give you the exact result right now. However, for the preliminary conclusions, I can mention some of main points. The first one, Indonesia has raw materials and the potential to be an EV player in the world, along with China is the number one, and US, because obviously we have the important ingredient for the battery. And then we can make sure, we can expect that the number of EV would increase significantly in the coming years, because those factors that I mentioned before. However, to manage those risks, we have to see a couple of things. So the first one, we need to promote EV for public transportation. So if you want to see less traffic jam, we cannot just promote people to buy EV for private, but we need to promote it for the public transportation. So we have to change the behavior of the people. And then the second one, there are three critical points. The first one is the raw material extractions. So the government needs to have more strict regulation about the waste management, and also technology to extract raw materials from the earth. And the second one, for the source of electricity, we need to gradually change from the coal-based power plant to more renewable resources. And then the third one, for the battery waste hazard, we need to have recycling facility. So if we going back to the first question, is EV really cheaper, really cleaner or sustainable? I can say yes, only if we can mitigate risk on those critical points. I'm Isardita Pamuditama, thank you.
Okay, thanks to Professor Isardita Pamuditama, PhD, for the information and knowledge which have been given to us. May it be useful for us. Once again, give applause to Professor Isardita Pamuditama.
We move to our second speaker from Universitas Gadjah Mada, Indonesia, Professor Beta Maya Sopa, PhD. We expert on humanitarian logistics, energy modeling, and policy.
Please welcome Professor Berta Maya Sopa, PhD. Time is yours.
Thank you very much. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. You know, it's always nice to be here to meet you both in person and also by online. So I would like to introduce myself. My name is Berta Maya Sopa. I'm from Universitas Gadjah Mada. I would like to express my gratitude to the Dean of the Faculty of Engineering Universitas Brawijaya, and also the Vice Dean of Student Affairs, and also the Department Head of the Industrial Engineering, and also for the honorable keynote speakers. It's always nice to learn from the expert, of course. Here I would like to share our research work that has been done early of this year. So it came to by surprise for me that accidentally that the theme for my presentation is almost similar with the Isardita. So, but I think I would like to invite you to think more on the system perspective. So I would not to give you some details, but it's more like to make you think or to make you try to explore things that, okay, now Indonesia has been has a program to increase the adoption for the electric vehicle. So then when it comes to when it's reached to its lifetime, So what we should do? So that's actually the idea of my presentations. So here I would like to introduce you with the concept of the circular supply chains that has been applied to the electric vehicles in Indonesia. So I would like to give you 4 agenda. First, I would like to introduce some introductions on the electric vehicles, and then the concepts of the circular supply chain. Actually, it's part of the circular economy. And then I would like also to share what we have done from the last 6 months that has been published in the international journals. But it's more on the theoretical, conceptual, how we deal with the electric vehicle when it comes to the lifetime. And it comes to the conclusions. So here are some brief introductions that we know that the electric vehicles is, well, I would say that it's new in Indonesia, but actually it's not quite new in the outside Indonesia. I think in Europe, as far as I remember, when I was doing my PhD, it has been a hot topics at that time. But I think it's like 15 years after, then Indonesia is now like trying to keep up with the electric vehicles in Indonesia. As you see here that the adoption or diffusion of electric vehicles in Europe is very dramatically increased. It can be understood that most of the power generations in Europe is mostly based on the renewable energies, but not yet, I think, in Indonesia. So I think it poses a challenge that then the questions like, is it really environmentally friendly for electric vehicle adopted in Indonesia or not environmentally friendly? So actually, Pak Ishardita has asked the questions, and I would ask the question one more time. Then maybe I give you some perspective that based on other research that it depends in many factors. Then I will discuss that more about that. So because Indonesia wants to achieve the net zero emission by 2060, as far as I remember, yes. So one of the policies is that Indonesia would adopt the electric vehicles with the assumptions that electric vehicles is release no emission of CO2. It corrects, but it's only in part of the systems. So here we see that government is very active and also aggressively to facilitate this adoption through the regulation, particularly for the battery and also for the taxes and etc. As we see here that the number of the electric vehicle has been increased. I think, yes, you can see from the pictures that currently there's 16,000 electric vehicles has been there in March 2022. So, and also the development for the infrastructure, for the charging infrastructure, it's also has been increased. In addition to that, government also prepares some regulations, although it's more likely focused on the battery and also for the, I would say, the infrastructure for charging station or for the battery swapping and etc., but not yet has been touched upon the standard. Now the question is, okay, if we think that Indonesia is very populous countries, I think it's the the most populous country in the world, right? If you think like, okay, only just 1/4 the population adopt the electric vehicles, could you imagine in the 20 years after you adopt the electric vehicles? So we would have so much battery, and then as we know that the battery is not, I think, is not easy to handle, right? Because it contains many hazard materials that should be disassembly and also should be to recycle. So it's not easy, right? So then the question is, the electric vehicles really environmentally friendly? If we only look at the operations of the electric vehicles, yes, we all know and we all agree that the electric vehicles is non-zero emissions because it emits nothing, right? If we compare with the conventional vehicle, of course. So here we have a black smoke there, but there's no smoke over there. But as we know, but Hardita also touched upon that if we talk about the electric vehicles, we are not only just look at the operation, not only look at the use of the electric vehicles, but we also need to consider the process or the operations that leads to the use phase. So actually here we have three types of the supply chains. You can consider if, okay, I'm now I'm driving my vehicles. So you can think that how can I use now? I use the electric vehicles now. You can think that, okay, these vehicles need to be manufactured, right? And also to manufacture the vehicles, it needs raw materials. So we have these supply chains on the car life cycles. But in addition that the vehicles can be run, we also need fuel. So we here also have another supply chain, as we call it here, the energy carrier life cycle. So we have to think like, okay, where's the electricity comes from? Okay, it's from the PLN. okay, but then how the PLN generate the electricity? As we know that most of the electricity in Asia is generated from coal. So, but one more thing that most people maybe neglect this is that these cycles, this life cycle, after you use or after the electric vehicles has reached its lifetime, where does it go? Can you think about now? I think like, okay, if I have old vehicles, where does it go? Maybe it just go to the workshop, and some people just do or disassembly the cars. But some in Indonesia, it's very common that the old vehicles transported to the remote area. It's also a very normal practice at that time. So here we need to consider these three types of life cycles, we call like life cycles of the electric vehicles. If we think about that, so we can understand that maybe here the use phase is non-zero emissions, but we just shift the emission go to the fuel production. It means that if we need or if we use more electricity, means that we need to burn more coal. Burning coal, you know, coal is very high emission for CO2. And CO2 is a high contributor for the global warming potential. So we need to address this. Otherwise, we will answer that, okay, electric vehicle is non-zero emission, but actually it's not. If we also consider the fuel production and also the car life cycle end of life. So now I give you some proof. It's based on the research results early in the 2010 from the International Energy Agency, that they have this profile where the reference is conventional vehicles. If we see that it's the CO2 emissions for the battery electric vehicles, which generated where the electricity generated from coal, the emission is not more better than the conventional. So means that if we have electric vehicles, at least if we compare the emission for the CO2, it means that using the natural gas, at least using the natural gas, it will be as good as the conventional vehicles. Of course, the natural gas is still fossil fuel, right? It's not renewable energies. So we need to think about using renewable energy. So it can be understood that electric vehicles can be environmental once the electric production is based on the renewable resources. That's the idea. But in fact, if we look at the left sides of the picture, Indonesia has, even Pak Hardito has proved that around 68% from coal. But here I got it from Statista that Now Indonesia has around 56% from coal. So I mean, it gets better, but still it's not enough. As you see here that at least all the electricity generated from natural gas to be better, like comparably better than conventional cars. So that's what's our condition right now. So it means that if we want to make the electric vehicle is environmentally friendly in Asia, so we have to think other renewable resources other than the coal. Okay, now it's a old results, but then let's check to the other environmental impact. So far, we have discussed only the global warming potential, but actually we have different types of environmental impact. For example, like the human toxicity and also the depletions, material depletions, and also for freshwater eutrophications. So if we look at this picture, we know that, of course, for the global warming potential, maybe the electric vehicle can perform better than conventional car. But actually, it's depend on the technology that you use in the electric vehicle, right? We have 3 types of electric vehicle as mentioned by Pak Ishardita, the battery, a plug-in, and others. So here we see that based on the human toxicity potential, the electric vehicles perform worse than the conventional cars. If we talk about the human toxicity potential, it means like we try to solve other problem, but then we create other problem in different places. So we solve the global warming potential, but we create other human toxicity potential. So it's based on the means that what I would like to invite you to raise the attentions that now we have to think to explore alternative solutions, that we have to make sure that the solution will not create other problems in the future or will not create other problems in other areas. So we have to ensure about that. So to do that, we need to look at in the system perspective. So that's what we call the problem shifting, that we try to solve something, but then we create other problems. Then if we look at the new research that has been done in Hong Kong, I think it's 2022, the result is similar. So I assume that with the development of the technology, the profile of the environmental impact is not different than 10 years before. So it means that we have to be aware of using the electric vehicles. Otherwise, it will not create better environment, but it can make a worse environment. So then what we should do, because the government has already pledged that we are going to that directions. So now I would like to introduce with the new concept as we call the circular economy. Because now, usually, traditionally, we only use this linear economy, that we extract the raw material and then we produce and we distribute, use, and then by the end of life, we just throw away to the landfill, right? But now, how is we think that, let's say that how our systems can be work as our ecological system. Mean that we know that in our ecological systems, they have a circular flow where the output of the other process will be the raw material or the input by the other process. So that's why I would like to invite all of you to think about that, because there are many solutions or many alternative or many innovative ideas that you have that may contribute to this. So the circular supply chain is part of the circular economy, where we try to make or develop the systems where we try to less use the raw materials and also less produce waste. So here, if we use the circular economy, by the end of life, we try to find ways by reuse, refurbish, remanufacture, or even to recycle. But as far as we know now, the recycle it will come back to the similar supply chains. But for the circular supply chain, is not always coming back to the similar supply chains. But we could also make a difference or can be used by other supply chains. So that's the difference between the closed loop or maybe the green supply chain with the circular supply chains. Because some people say that, okay, if we consider the CO2, we call it green, but actually it's not quite green. As long as if you ensure that all the material can be recycled, then it's green. So that's the idea of the circular supply chain. So we only not working in the similar system, but we can also work in the different system. I give you an examples like the plastic bottle. We extract the from the materials, and then we produce to the bottle, and then its final use. Usually we think that, okay, the bottle will be pressed and then use the plastic again to make another bottle. But actually, if we use the closed loop supply chain, that's it goes. But if you use the circular economy, the plastics can be used to a different products like textile or maybe toys. It has been applied by Nike and Adidas as far as I know. So then if we do that, what will be the benefit? Of course, if we apply the circular supply chain, we will reduce the raw material, and then we reduce the waste because we try to use materials back again to the supply chains. So it means that we less use the raw material and less produce the waste. And then, of course, by that, we can reduce or we can have economic benefits and also reduce the environmental impact. And eventually, we can create some resilience. Because if we are not depending on the raw materials, like Pak Isfardita has mentioned, for example, for the battery, only just a few countries has produced or has the resource for the cobalt, for the nickels. So if we use the nickels or cobalt reuse again for the battery, so it means that we create less dependency to other countries, and that creates a resilience. So, but the thing is that try to transitions for the circular supply chain is not easy. There are many factors that has been influenced based on our literature review. There are the 4 factors that can significantly influence the transitions. The first is technology and infrastructure. So particularly for electric vehicles, it's very new. No one knows, like for the battery, for example, the lithium-ion battery, the technology is very changing, evolving over time. So the way that we try to recycle is not also easy. It's not only well known for now. So that's poses a challenge, of course. And then once it's ready, we also have to set up the supply chain operation to make sure that we took out the battery and we disassembly and going back to the producer to disassembly the battery to make sure that these streams are streamlined. Otherwise, it will not be economically profitable, right? And then for now, the economic factors has been inhibitor because there's no because of the risk, because it's the new things, new issue, the risk is very high. So then the incentive is not available yet. Even in Europe, some recyclers has problems that because the recycle process is very expensive, but the government has not yet provide the incentive. And also the important things is about the policy and regulations, particularly for the safety standard. And then the last one is the social. I think it's also very important. Can you imagine if no one, after the battery has been used, no one want to return, no one would not return to the producers. So how can the producer can disassemble the battery and reuse the battery? So it's very simple for us. For example, like if we want to throw the waste, do you want to spread the waste according to the type of waste? I think not everyone want to do that, because it's like it's not convenient. You have to split out the waste and then put the different bin. So that's the things that we need to. So the social things is very important in this case, because the operations is depending how much of the scale of the used products, I would say the used products can be returned to the process. So here I would like to just address or to give you some information that we have published. Here it's the barriers and the enablers for circular economy. It's very general studies. It's based on the literature review because we expect by the findings of the research, it will be helpful for Indonesia to develop the system, particularly for recycling, reusing, refurbish for the components of the electric vehicles, or at the end that we will have systems that has been established for the circular supply chain for electric vehicles. So first of all, I would like to introduce that we need to understand in the electric vehicles, the different types of the components that has a different characteristic, different natures that needs a different treatment as well. So what we call it here in the waste hierarchy. So we need to understand which component that can be recycled, which component can be refurbished, remanufactured, and maybe some components can be done anything. So we have to just to do it landfill, but it's the last resort for the recycle. So to do that, we also need to address that there are different critical stakeholders. Actually, there are many stakeholders, but here I would like to introduce you with it. There are 3 critical stakeholders that should be actively involved in the transition processes. So here's the government that played a role in formulating policy regulation, giving the incentive, because once the cost is too high for the industry or for the, I would say for the industry or for the private, so the government needs to give some incentive, otherwise it will not work. And then also the manufacturers that responsible for the technology and also for this assembly process, because they already have the technology there, they have already the competence there, so they need to be supported to evolve the technology further. And also the recyclers can be the manufacturers or could be different parties from the manufacturers. And the recyclers here also play an important role how to collect the used products and also to streamline the process to the disassembly. Here's the barriers that we have identified from the literature review. And here it's very many barriers, but I would like to highlight the more important one, or most the reviews has identified that the inefficient and adequate government policies and also lack of the safety standard for the battery, for this assembly battery is the most barriers to do or to implement the circular supply chains. And on the other hand, for the enablers, so the enablers is that the standardization it's very helpful for the implementations and also for the collaborations among the stakeholders within the supply chains, or the innovative business model and the economic incentive and the legal environmental responsibilities would have to implement the circular economy. Means here that we need to use different approach, like innovative models. For example, I would like to give you some example, like now we only not think about the products, but we need to think about the service of the product. So it means that the product is not owned by the consumers, but the product is owned by the manufacturers. It implies when the product is owned by the manufacturers will responsible to all where the flow of the products and responsible to track and trace where is the product is. So then it's very easy to return the product. So for the consumers, we only think that, okay, I use the product because of the service. We use the service of the product, not the product itself. So it means that here as the customers that we need, because we only just need the service. So maybe leasing would be appropriate in this way. So in addition to the ownership, because the ownership belongs to the manufacturers. So that's the examples of the innovative business model, or we call it like a certifications. So we focus on the service other than the products. Okay, now then based on the result, we try to build the framework that we know here that the electric vehicles is extracted from the natural, and then we use the raw materials and goes to all the supply chains here. And then we understand that particularly for the battery, we need to understand the state of the health of the battery. If the battery is still good, so you can just reuse it. Otherwise, if it's good battery, but the capacity is still more than the 80%, so we can use the path of remanufacture. Otherwise, if it's poor battery, so we need to recover the component of the battery. We cannot use any more the battery. But if the battery is still good, but the capacity is less than 80%, so we could use that for other purpose, or we can use like for the energy storage for the PV, or energy storage for if the electricity blackouts occurs. It can be then it can be stored, the electricity, it can be stored in the battery. So once we know the path or the circular supply chains, then we need to understand what we could do, or what the strategy that needs to be done in the different processes. So here, based on the analysis, we try to split into two different strategy. The first one, the first one is strategies to establish the circular supply chain for the electric vehicles. So we listed based on the reviews that innovative business model, economic incentive, standards, responsibility, and certifications would help to build, to establish at the first place for the circular economy. And then once we have already established, to make sure that the process is efficient, or to make sure that the process is technically feasible, economically profitable, so we need to adopt these types of strategy. So first, I think for people, or for you who really interested in the design, so you could do the eco designs. Means that while you design a product, you need to consider not only just in use of the in the use phase of the customers, but after use of the customers, you need to think about that. For example, if I have a microphone here, if I know that there are some components that I can disassembly that, so you need to think how to design the microphone that after its end of life, I can be easily disassembled. So now I think it's a challenge for the product designer. And in addition to that, maybe some concept about the modularization that we all know. I think it's very common strategies in supply chains can be adopted as well. And also for the technology for checking or tracing, because of the nature that the battery can be recycled, which part of the battery can be recycled is very dependent on the state of the health of the battery. So because of that, we need to understand how many, how frequent, how the customers use the battery. In that case, then we know the right path or the appropriate path that the battery should go through. In addition to that, so the stakeholders among the suppliers should be streamlined, not only for the process, but also supported by the information sharing. So they have to collaborate, sharing the informations, and also align between the stakeholders. And the last time, I think it's very important to seduce the customers that the reuse product is not as bad as I mean, like the reuse product has a good quality as the new one. because some people like, oh, it's a used product, so maybe it's the quality is not that high, or the quality is very poor. So we have to ensure that the product is as good as the new one. So the certification is really helpful to ensure that the customers wants to use the reused products. So based on that, we try to sorry. Okay. Aduh, oh, can you? I think. Sorry, I'm going too fast. Please go to the slide, maybe 5 slides before the end. Sorry for some disruption. I just want to give you some summary that there has been a gap between the strategy that we already have now and which strategy that needs to be done in the future. Nah, this one. So here, yes, thank you. Yes. So the current strategy that we already adopted now, that we miss the strategy regarding the supply chains and the economics. But we now have already in some countries they have already developed the recycling technology, and also they have the instrument that can be used to check and to trace the battery. And also some countries, a very few countries, has a policy regarding the extended producer responsibility. I mean the producer, the one who produced the product, has responsibility to return or to collect the product after its lifetime. And for now, the social aspect is still voluntary. So there's no obligatory for us to, for example, to return the used products. But to be able to implement the circular supply chains, we need this. So it means there's a gap that we need to really understand and to really adopt it to make it work. So eco-design, the digitalization, modularization, as I said earlier, the certifications and leasing platform would be an options, and also economic incentive, the standard, particularly for the safety standard for disassembly the battery, and also certification, social commitment is very important to implement the circular supply chain, particularly for the battery. So to conclude. No, I think I have problem to to move to conclude. Yes. So as we know that it's very complex, but it can be done. Implementing the circular supply chain is not an easy task. So there are many different facets that we need to address. There are many different challenges that we need to face. So here, as academicians, so I would like to invite you. Maybe we can split the work, So then we can work together. Like, okay, for designer, maybe work on the eco designer product for the supply chain. So we will try to understand the overall process that facilitates the flow of material, of the flow of the used battery, and then we try to optimize the flow. And for the ergonomics, maybe start working to try to safety standard for disassembly the battery. I think all of us can contribute to make it happen before it's too late. Because now it's still, we are in the early stages of the electric vehicle adoption. But can you imagine after 10 or 20 years, after most of people very eager to adopt the electric vehicle, if we don't have this, so what would, I mean, I'm sure that it will not a good solution for us. Because if we do nothing, then we know that it will create another problems. Okay, and then yes, the transition strategy towards circular economy is the access and also the optimized operations is very important. So to make sure the access, so we are not dealing with the process itself, but we deal with peoples who has a high awareness that the used product should be returned or the used product can as good as a new one. It's very important to ensure or to increase the awareness of that to our society. Okay, then we as industrial engineers, I would like to invite you, as we know that industrial engineers is also try to explore or try to find the best way to do that. But since now we have a concern about the sustainability, the environmental problem, and etc., we need to find the best way and to make sure that our solution that we have now, it will not create other problems in the next generation, or will not create the problem for in the different places. So with that, I would like to end my presentation, and thank you very much.
Okay, once again, please.
Please give applause to
Professor Becca for sharing with us a good topic.
So our third keynote speaker is an expertise on human factors engineering and occupational safety and health management.
Please welcome Professor Yasirli, PhD CPA from Institut Teknologi Bandung, Indonesia. The time is yours.
Tes. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Any problem? Okay, thanks. Yeah. First of all, I'd like to appreciate the organizing committee and University of Brawijaya for inviting me here. I think the last time I visited Batu around 5 or 6 years ago. It is always a great to visit Batu, and I think that's all of the participants, I believe that we'll have the good time here. I want to appraise my respect to Dean of the Faculty of Engineering, Universitas Brawijaya, and Vice Dean, and all the Department Chair of the Industrial Engineering of Universitas Brawijaya. Okay, based on the conference theme that what we have today, talking about the building sustainable industrial systems for resilient society post-pandemic, I would like to give you an idea, insight from the different perspective after we hear the previous two keynote speakers talking about the battery and the electric vehicle. So I would like to talk a little bit about the ergonomics rules for building sustainable and resilient system post-pandemic. Here, I'm sorry, a little bit about my background. Currently, I'm the co-chair, ASEAN co-chair for Professional Standard and Education, International Ergonomics Association, and most of my works related to human factors and ergonomics. Here my outline. I would like to start with the 3 keywords that what we are discussing today. The 2 is sustainable and resilience, and I would like to add 1 more keywords, which is ergonomics and human factors. After that, there is a lot of discussion among the experts about how ergonomics, using the ergonomics and human factors point of view to integrate their perspective, their methods, and their research to sustainability and resilience. And before I close my speech, I would like to propose to all the audience here some directions for building ergo sustainable resilient systems and what the proposed approach that we may to consider. Ladies and gentlemen, let me start with the basic concept of ergonomics and human factors. As we may know that ergonomics and human factors, we focus on interaction of human with the other elements of the systems. And our main goals is to optimize human well-being and overall system performance. I'll highlight the goals, which is later on relate to what the theme also, the target, the goals of the sustainable. The way we do our ergonomics work, we look at the physical factors such as anthropometry, physiology, biomechanics. We also look at the cognitive factors, talking about perception, memory, decision-making, and the last one, we look at the organizational factors. Based on these three factors, IEA has divided the domain of ergonomics into three. The first one, physical ergonomics, here concerned with human anatomical, anthropometric, physiological, biomechanical characteristic. A lot of research, what we are doing about the design, later on talking about the how to design towards sustainable and resilient system just based on the physical factors. The second domain is cognitive ergonomics. We concerned about the how people starting to receive the information, perceive the information, and then later on how they come up with the decision for the action. And the third domain, organizational ergonomics, concerned with the optimization of socio-technical system. These three domain, if you look at all the starting from the micro level to the macro level. Micro level, more focus on the physical and cognitive factors, and more macro level, we are talking about a socio-technical system. That's the first concept. Let's move on to the second concept, sustainability. Actually, when we are talking about sustainability, it's not the new term. Based on some literature that I'm trying to look at, the idea has been discussed since 1972. And at that time, and till now, when we're talking about sustainability, it means that the development that provide current needs without treating future generations' ability. And the goal is to improve our quality of life and quality of our work. So by looking at these definitions, there are two implications. The first one, company must continuously meet the society needs. And the second implication, corporate sustainability must look at the long-term business. It's not only the short-term goals. And they need to look at the both in balance. And when we're talking about the sustainability, recently, also gained momentum. The first one, due to the scarcity of our national resources, Buberta also mentioned about the regulation, government regulation, and increasing demand. Our customers want to see more products, more policy, more process, which is they think that's more considering sustainability or sustainable development. And also United Nations has mentioned about the 17 SDGs that everybody talk about this and how to relate their work, their company to those 17 goals. And last but not least, When we're talking about sustainability, people also talking about what they call as the triple bottom line, 3P, people, planet, and profit. Okay, based on these two concepts, let's think about can we integrate the ergonomics to sustainability? Actually, both has the same common goals. Ergonomics, as I said before, we're talking about how to optimize human well-being, and sustainability as the same thing. We're talking about the quality of life, quality of work. And here, if we compare the two, the first one, let me start with the ergonomics and human factors. People has mentioned about ergonomics, the key strategies of ergonomics and human factors as the key success design for usability and user satisfaction. When we look at the sustainability, people also mentioned that sustainability has become the forefront in business around the world. If you look at the number here, more than 13 trillion has been invested in socially responsible companies. Look at the method, actually. Ergonomics and human factors can be applied, as I said before, starting from the micro level to the macro level. And in terms of the cost also, number of research mentioning about the high cost due to unergonomic design, due to the unergonomics, even design of product, design of process in their industries. And ergonomics also has been thought as the new approach, the way we look at how to increase user satisfaction. And one more thing about the sustainability, there is data I took from the Cardinus.com. Interesting, 92% of Y generations, they are more likely to work for an environmentally friendly company, and they want to sacrifice about 6% of their salary if they work for a company that more consider sustainability factors. So based on these two discussion, in literature, we've looked at that there are two different point of view. The first one, what mentioned in 2013, do we need sustainability as a new approach in human factors and ergonomics? That's one, one point of view. Another point of view, ergonomics seems to be a missing part of sustainability. So people say that for successful implementation, does sustainability need ergonomics among its design approach? Which one is better? Actually, if you look at the more detail, how experts try to debate and try to think about which one is better, actually both are correct, both are true. So the goal is actually not which one is ergonomic for sustainability or sustainability for ergonomics, but the common is how are we gonna integrate ergonomics and sustainability? Here are some notes from the International Ergonomics Association. I took from the website. Actually, IEA has considered sustainability as among the main goal of our ergonomists. It's written that human factors and ergonomics contributes to the creation of safe and sustainable work systems. And I think that's for industrial engineering, Bu Berta, we need also to expressly mentioning that all our design must consider sustainability issue by considering interrelatedness of human, technical, and environmental components. One more thing IEA mentioned that members of human factors and ergonomics community must recognize the need for participation of all stakeholders, from the government and also from the society. And here how human factors and ergonomics can contribute to safe and sustainable systems through a unique combination of the three drivers. The first one, we can take a system approach using systematic, iterative, step-by-step process. Second, we could use the design-driven. And the third one, we could focus on optimizing two closely related outcomes, which is performance and well-being. So based on this one, actually IEA already mentioned about the need to integrate sustainability and human factors and ergonomics. How all of our works should be designed toward one aspect, which is the sustainability. And if I'm not mistaken, since 2010 something, that's IEA has declared one technical committee in ergonomics or human factors in sustainability. So among all this here, the list of IEA technical committee, we can see that there is one technical committee focused on human factors and sustainable development. And I believe that some experts have worked and have a discussion, several seminar, webinars, and also working papers relating to the sustainable development issue. So the next question, okay, we already realized that ergonomics and human factors have common goals. We can integrate ergonomics and sustainability have common goals, and we need to integrate ergonomics, human factors, and sustainability. The next question is, how are we gonna integrate both? There's one paper, I think that's good one to start if you look at how ergonomics relate to the issues related to sustainable development. Starting from the method and technique, human characteristics, work design, and organization, and all of these related to sustainable development. The basic, I think that there are three concepts. The first one, workplace design and environmental ergonomics can promote well-being and protect environment through energy conservation and green building. That's what I think that's our the two previous keynote speakers talking about the battery and electrical vehicle. The second, actually, in terms of more particular on health, safety, and environment subdiscipline of human factors, HSE and work design can promote business sustainability. That's the third keyword that we're gonna talk about this later. And the third one, organizational design can promote social and ergonomic sustainability. So that's the way, the concept that how ergonomics can have a role and contribution to sustainable development, sustainability of sustainable development. Let's look at some research that nicely done by some ergonomists around the world. Some of them designed for sustainability in healthcare. And Tosi, she wrote a good book about the ergonomics in design. Has also publication 2012, Design for Sustainability of Daily Products. Another researchers proposed about anthropometry in designing for sustainability, sustainability on manufacture work, sustainable products manufacturing. Actually, that's, if you look at this publication, that we can see that so many things, that point of view, time of design, focus on specific aspect that ergonomics, we can use ergonomics to answer the need for sustainable development. Here, some more detail that I've used in my class. Actually, this semester, I have 2 elective courses. The first one, design for ergonomics, and then the second, macro ergonomics. And among the slide, I use this one. What the good thing about this design? The first one, trash bag that can sing a song if you put something, yeah, in the trash bag. This kind of how we think about the design that might promote cultural change, yeah, based on the issue of sustainability. The bottom one, the first one, what the interesting about this glass? Any idea? If you go to party, the problem is so many people, yeah, take juice, yeah, full of the glass, and then they just taste it and then put it away. How many ways that, yeah. And by designing such of a glass, what's happening? People just take as much as they need. That's the idea, actually. What about the second one? Yeah. Now people talking about the user experience. Yeah, user experience. I think that's for what I said. That's why generation. Yeah, if they have their office like this one, is gonna give them kind of different user experience. This is just a sample of, if you look at the before, number of research, number of innovation, number of products we can, yeah, propose. If you look at the how ergonomics, looking at the ergonomics point of view, and as well as sustainable, the need for sustainability. One work done by Lean 2019, I think that's, yeah, they done a good work proposing a framework of ergonomics-based factor for sustainable product manufacturing. So if you want to, okay, how good my product in terms of both ergonomics and sustainability, we can start by looking at these three dimensions. The first dimension is employee-centered product, by looking at the social employee well-being dimension. The second dimension, economic dimension, and the third one, environmental dimension. So, Pak Is, if you want to, for example, evaluate, yeah, your electrical, yeah, car, yeah, not only we look at the end-of-life product environmental dimension, we need also to look at the employee-centered product that may have an issue as well, and also user-centered and resource-efficient product in terms of economic dimension. And the detail of each dimension, occupational safety, health, this the parameter, and then simplicity for production and maintenance, yeah, this parameter related to easy to manufacture, easy to assemble, easy to disassemble, easy to inspect and test, easy to repair, and etc. and etc. This, I think that's, yeah, one good work proposed by Lean 2019, how we look at how we can integrate ergonomic aspect in designing also sustainable product. Let's look at the history. As I mentioned before, when we're talking about the sustainability, it's not the new term. People have discussed it since 1972. And if you look at the how our expert, our guru in ergonomics have also proposed some approaches how ergonomics relate to sustainability. And I will show you at least 3 approaches that are interesting. The first one, the concept of ecological ergonomics, proposed by H 1992. The second, green ergonomics, proposed by Thatcher 2013, and system of system approach 2016. Let's look at the detail. The first one, ecological ergonomics. So starting from 1992, yeah, actually have invited Alan H. in Bandung about 6 years ago, actually. And he did a presentation about the green ergonomics. Yeah. What the Alan H. idea actually, ecological ergonomics is combination of ecology and ergonomics. Ecological ergonomics describe the study of the processes, conditions essential for creating and maintaining habitable and healthy work environment for people. And ecological ergonomics covers diverse array of work environment factors that influence worker health, satisfaction, and productivity. And he came up with his proposed model, looking at how office environment condition and corporate culture may affect, starting from lighting, thermal comfort, video work, etc. 1992. The second concept, green ergonomics, about 10 years ago. What is green ergonomics? Define ergonomics intervention that have pro-nature focus, specifically ergonomics that focus on human affinity with the natural world. That's what we have known now, how ergonomics, especially in terms of product design, and we think about our scarcity of our natural resources, and then we think about how we can design product that's less energy consume, less the material waste, and etc. That's what we call is green ergonomics, and which is also the broad concept. The third one, that's just a new concept. I think that's we have just also discussed with those Thatcher and you about the system of system. This is interesting actually. What we have known so far, we're talking about a system design, but they propose about the system of system. We cannot just look at the system at one level. We need to look at the system and the system at each level and how each level can interrelate it one to another. This paradigm shifts to think beyond a bounded linear model understanding toward a broader system framework. And they argued that why this approach is needed, because there are three components. The first one, the nested hierarchy of complexity. The system has become more and more complex. The second, focus on multiple simultaneous goals. The problem, the challenge is, if we think about the one goal, it seems easy for us to achieve it. But if so many goals, for example, that if I list the ergonomics goal and as well as sustainability goals, and then we start to confuse which one's more priority and others. And they argue that by using this approach, we can overcome that challenge. And the third one, consideration of issues over time. They look at that here, this general approach that we have already known, starting from individual, teamwork, organization, inter-organization, from the micro to macro ergonomics aspect, and more specific to sustainability, they propose kind of model looking at starting from the individual, and then also starting from going toward to more macro into ecology, ergo-ecology, green economics, and etc. Some keywords related to work-life balance, contribution labor legislation, occupational safety and health, and interaction becoming the key of this model. It's clear, okay? So, if we look at the ergonomic and sustainability, what I can conclude that at least here our homework. What kind of research, what kind of method we can do now, at least for now and the future. The first one, design for low resource system and product, which is talking about the product sustainability that we have discussed about it a lot. Low energy use, pro-nature material. This also area, sub-area designed for green jobs, which is process sustainability. How we come up with the facilities, technology, smooth operation that enhance eco-efficiency and eco-effectiveness. Yeah, people mentioning about green technology, green facility, green building, and etc. The third one, ergonomics design for behavior change. That's something that's, I think, we paid less attention on this issue. How the design can change our behavior toward sustainability. And I think that's, yeah, we could do that. As I said before, that there are three picture example of the design. Design eco-labeling of product, just an example, informing users about appropriate practices and etc. etc. And there are two more that's, yeah, the research that's what I'm doing right now, how we building a sustainable organization, looking at by using the macroergonomics approach. And it is also interesting to look at how the system approach, Bu Berta, working on sustainable supply chain. Okay, the next, my presentation is about the resilience. Yeah, I think that's, yeah, we have not touched these keywords. What is actually the resilience? The popular term is resilience engineering, RE. The capacity to recover quickly. That's the idea actually. Why people talking about the resilience? Actually, if you look at the literature, people have mentioning resilience around 2000 something. But after pandemic, which hit us a lot, people starting saying, okay, resilience seems more important than everything else. Yeah, productivity, economic, or etc. Resilience engineering is system-oriented, regards variability as an inevitable portion of everyday work, which is responsible for both desired and undesired outcome. Also, resilience, what is resilience? Performance, system property that enables adaptation, survival in face both expected and unexpected circumstances under high complexity condition. So the discussion about the resilience become more and more important because there are four drivers that we have now. What are unpredictable future, more complex system, learning ability of our workers, and organizational agility. So one work again done by Thatcher. He proposed design consideration of resilient systems, something that's we need also to add. So after we're talking about ergonomics, human factors with number of goals, and then we're talking about the resilience with the number of goals, and then now there are four more need to add on our basket. What are there? The first one, diversity, adaptability, cohesion, and efficiency. Efficiency may already have on our basket. Multiple product configuration extension option, diverse business strategies, end user customization, adaptability, organizational learning, flexibility of leadership, transparency and flexibility, and etc. etc. All of kind of that we may have not discussed yet or considered yet in our work about diversity, adaptability, cohesion, and efficiency. Something that's interesting, I just had the project with the Pertamina, the project called how to change safety behavior and building safety culture based on human and organizational performance. So actually, if you're talking about the resilience, those our friends from the human factors and health and safety management already discussed about the safety 2. Everybody has heard about that? What the difference between safety 1, safety 2? Yeah. The expert is Eric Hollnagel. I think that's, I need to appreciate, a long work that he has done. And if you look at here, safety 1 focus on accident. So if you look at the almost whole of our companies, ask them about what their program in health and safety management. And they will say that accident investigation is among the priority. And then they want to build huge system just to be able to learn from any accident that happened. Look at this figure. Okay, this time, if we look at the actual standard operating procedure, how the SOP is designed, and this line. Okay, and the actual how workers perform their job, actually this kind of random. Sometimes, not sometimes, most of our time actually do not follow SOP. Agree? Yeah. Sometimes they did something that good actually in terms of the performance, and sometimes they're doing actually negative. Negative due to they don't have the appropriate equipment, due to weather, for example, of they're sick, etc., and they may do some things that actually may affect the safety performance of the system. And sometimes not, one thing that could be once a year, once couple years happen, what we call as accident. But most of the time, actually, accidents do not happen anything, because we have here the safety lead. The safety 1, the conventional approach, they focus on the accident, which is very, very less frequent. The chance is 0 point something %. But we miss a lot of information how the actual things workers performing their job. That's why Hollnagel thinking about, okay, we got to change. There is need of shift paradigm. Instead of looking for something that very rare happen, which is the accident, we need to look at that how actually the people work comparing to their SOP. Here, what we call as work as plan versus work as practices. Resilient system can be built if we can know what happened while there is no accident, and we can learn how workers can do their works, what we call as successful works, and we can learn from this successful works. So a number of successful works, there are only 2 questions. The first one, are we lucky, so there is no accident? Or, yes, we really have the resilient system. So based on this, we can learn, actually, that's the focus of safety 2. Safety 2, one approach that we can use how we can build as a resilient system. So based on this concept, this approach, thought people in health and safety environment management, HSE, starts to think about how to build error-tolerant organization, starting this from the thinking of error-tolerant system to error-tolerant organization. So if we can produce what we call as error-tolerant product that can prevent us to make mistake, so basically we should be also able to building a resilience organization, which is error-tolerant organization. And here the steps starting from designing for resilience from beginning, building with redundancy, multiple layers of protection, testing and verifying the protection, monitoring, and taking action when things go wrong, recoverability of the system. And the good example is the Volvo. Volvo, starting from 2020, they didn't have what called as zero accident. Then they said that zero accident is nonsense. But the true thing is zero fatality. Accident may happen, error may happen, as long as we have resilience in our system. And it is okay. Yeah. And the second approach, what I'm trying to disseminate now in Indonesia, what called as human organizational performance, proposed by Todd Coughlin, 2016 something. And HOP has 5 principles. The first one, people may make errors. Nothing bad with the people make mistakes. Second, learning is vital. As long as you can learn from both successful and unsuccessful work, you will have great insight how to build a better system. The second, and the third, blame fix nothing. So you got to build also culture that everybody can report any potential problem, any potential error, or even any minor accident. Blaming fix nothing. Context draft behavior. Every workers may not follow SOP, the standard, due to something that they think that they are correct, the appropriate for them to do that. So that's why learning is vital. We got to know why workers do such kind of variation, or even innovation. And the last one, response matter. How management, leadership responds to all this, both the accident, non-accident, any near-miss accident, all are matters. So, based on this, I would like to propose in this conference what we call as Ergo Sustainability and Resilience System. And if you look at the concept of ergonomics and human factors, and the second one, concept of sustainability, and the third one, concept of resilience that we had just discussed, I think that the common things, the overlap things is only two. The first one, preservation and development of human and social capital. Even in terms of skills, health, motivation, participation, I will gonna touch about it a little bit later. And given that all work systems are open system, please, when I talk about, as I say, means I have said previously, there are 4 drivers of resilience. The first one, unpredictable future, and then stressor from the environment. So, organization must consider 3 macro ergonomic approaches. What are there? The first one is joint causation. All internal subsystems jointly affected by or are open to environmental stressors. Second, joint optimization. So the key, if we have a lot of goals need to achieve, we need to think about the joint optimization. How are we going to design human factors, technological factors, organizational factors, internal environmental factors, by looking all these factors and come up with the one design that optimum for all. And the third one, joint design. To develop the best possible fit between personnel and all the subsystem to design product, process, organization, we need to look at the building resilient system at each of the level. The first one, these things that everybody has heard about the Shuhari. Yeah, all about the human actually. What we have now in our industry, we're talking about industrial, sustainable industrial systems, the way we manage people, not different than what they have been managed since 19-something. Yeah. When we're talking about the manufacture, so we're gonna think about the mass production, and workers must do what they have told to them, and there is no space for innovation. This, I think that's Japanese or martial philosophies, Shuhari. Whoever doing a job, they do it every day, every month, every year, they're gonna have this kind of journey. Starting from there, just follow the procedures. I have no idea, just follow it because it's written by genius people. Just follow it. And then after that, they gaining experience. What they think that's, oh, yeah, due to any specific circumstance, they may break by accident. And then after they break the rule and they think, oh, I'm still doing fine. And I found that that's good for me, good for the system. So they're gonna be after that, they're gonna always break the rule. And after they break the rule, more experience, and they're gonna develop their own rule. They just follow the basic principles and they think that, okay, I'm the expert of this job because I've been doing it for years and years. This is the Shuhari. So if you're talking about we want to build sustainable, resilient system society, the key is about how are we gonna develop our workers. All is about the human. And the second direction that I think that's what I'm doing now, trying to develop what called as balance model as approach of macroergonomics. What the good thing about this model, we're starting from stakeholder needs, we're starting from the external environment to answering what issue related to resilience. VUCA, volatility, uncertainty, complexity, ambiguity. So before you think about what kind of product, what kind of organization goals, vision, mission, look at your external environment. What the VUCA level you are facing. And the design should start from this. And then, as I said before, joint design, joint optimization, joint cohesion will play after that. Look at the human, technology, and organization and how we can assemble of these three factors in a balanced thing. That's, I think that if we can combine balance model with the system approach, and the result will be great. And we can answer even so many goals, what we have in ergonomics, sustainability, or even resilient system put all together. So that's why I call it sustainability and resilience system. Okay, finally, here are my conclusion. So the first one, there should be synergies between the domains of human factors ergonomics sustainability. And I think that's integration. People have thought about this integration starting from about 10 or 15 years ago. However, still a lot of homework, a lot of, I think the customers, our millennial generation, Y generations, looking for more sophisticated products or process that can already consider sustainability issue there. And the second, there is emerging need for building ergo sustainable resilience system. We cannot just talking about the ergo sustainability. Resilience, people talking about the resilience now. Resilience becoming more important. Yeah. Even before pandemic, good company with the good financial record, and when the pandemic hit us and the company collapsed. They already have a good design, good product, sustainable design, sustainable product, sustainable process, but they cannot fight against external environment. And the last one, I'm proposing 2 directions for ergo sustainability and resilience system. The first one, all is about human. We need to give more space to our workers to have innovation. That's the idea. If we look at all the component of our system, technology cannot face unpredictable future. This part of the system that are be able to face unpredictable future is human. We need to give more attention to them. And the second, organization is also critical. It's not only about how to develop the human skill, human learning, but we need to create organization so that enable them to learn and have participatory to achieve the organization goals. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Yasirli. Professor, please stay on the stage. I'm sorry, please stay on the stage. Yes, here. And we ask to Professor Isardita Pamuditama and Professor Berta Mayasopa to join us on the stage because we will present an appreciation for your time to share an expertise in this session. And the appreciation will be delivered by the Department Head of Industrial Engineering, Professor Sugiono, PhD. First is for Professor Isardita Pamuditama, PhD. Second one is for Professor Berta Mayasopa, PhD. And the last one is for Professor Yasirli, PhD, SPE. One more. Thank you.
Okay, thank you for all the speaker on site for the good presentation and good topic,
Okay.
actually.
And that's not all. We still have three special keynote speakers from Malaysia, Japan, and United Kingdom. But because the unstable condition, our keynote speaker will join from Zoom meeting. So let's see if Professor Dr. Zuhriya Binti Ibrahim already joined Zoom.
Okay. Hello, Professor Zuhriya.
Hello. Already with us, Professor?
Yeah, I'm already here.
Okay.
So, Professor, are you ready to share your keynote speech?
Yes, thank you. Let me share.
Okay. Please welcome Professor Dr. Zuhriya Binti Ibrahim from University Technical Malaysia Melaka, Malaysia, who an expertise on sustainable manufacturing and lean performance. The time is yours.
Okay, thank you, MCs. Bismillahirrahmanirrahim. Assalamualaikum, and I think still morning. Good morning. First of all, I'd like to pay my gratitude to the chairman for this conference, Dr. E.S. Widha, and also the committee that for inviting me to be as a speakers for this session, and also to the respective Dean of Faculty of Engineering of University Brawijaya, and also for the head of the Department of Industrial Engineering, and also to adorable speakers, the three speakers just now. The content is very informative and can bring to more research in this case. And of course, to all participants, ladies and gentlemen. My name is Azura Ibrahim. I'm from University Technical Malaysia Melaka, which is UTM in short. Is the co-host for this conference as well. And I'm from attached at the Faculty of Manufacturing Engineering, which is my specialization is more on the manufacturing management. So related to the theme for this ISO IMIS 2022, my title for this keynote is revisit the model of sustainability concept in the era of global crisis. So it reflects to the three keynote speakers topics, which is the first one, and the second one is more details on the EV, electric vehicles, and the third one is more relates to the agronomic and human, which is more detailed pictures that we can see related to the sustainability issues. In my topics, I would like to bring the participants to let us revisit the model of sustainability concept because it's been established a few years ago. Okay, if you can see beforehand, which is why I bring this topic to develop or to develop the awareness among us in terms of the understanding the sustainability itself, the concept, how that we can contribute to this sustainability. Okay, this is my outline for the topic, my topics. The first one is a little bit about introduction about the sustainabilities, and then I'll go to the definition of the sustainabilities versus the sustainable development, and then I'll bring you to the overview of on existing models of sustainability concept that we can see that is actually quite ambiguous, the models. And then I bring to the quick view on the sustainable development goals that we have 17 goals. Very brief because if I like to go in details, that takes a longer time. And then I will conclude what we can have in my view from these three definition and the models and the goals, that what should the appropriate model of sustainability relates with this current global crisis. Right. So couldn't be agree that from Prof. Yasiruli just now that mentioned that the idea of the sustainability or sustainable has been started in 1972, but officially is that is been introduced and published by the United Nations in 1987. Okay, the definition of the sustainable development. So up to now, what we can see is in up to 2020 is already 33 years. Okay, with this 70 goals, how it goes, and we know that in 2020 is this kind of unforgettable years to everyone. What happened globally that we heavily impacted by the pandemic COVID-19. So the world's like freezing. We never experienced this along the 33 years. Yes, we have the small the other diseases like HIV and so on, but it's not as a big impact like this COVID. So the world's like freezing. That's why I it's like a globe like this, all white here. So we cannot move the activities. We have to stay at home. So this is things that unforgettable to us for those that experiences. And now it's been 2 years ago, really. So what we are going to do, okay, to get back to normal. So that is what we can see is a lot of innovations, the ideas, research, and it is very interesting from what we can have from the previous speakers just now. Right. So let's go through briefly, very basic, what we understand about this sustainability. So the very basic words is come from sustain. And now we can see that these people talk about the name things like with the sustainable sustainability. So what actually it is. So back to the we refer to the Oxford dictionaries. Latest one that is sustain is something that is keep exist. Okay, especially for the living. Okay. And another meanings is keep continue. That is refers to the things. So meanings, this is what basically means by the sustain. How to make it keep exist, humans, the plants, and how to make things continue. Like with traveling, continuous, and things that we do. Okay, so that is the basic. Right. So specifically, is all come the idea of sustainability is come from the concept or the definition of the what developed by the United Nations is a sustainable development. What is a sustainable? They start thinking about what will happen our future generation with what the activity that we have currently back 33 years ago. So what the United Nations stated that is meeting the needs of present without compromising the ability of future generation to meet their own needs. Meaning whatever that we have right now should be that our generation have or even have a better what we have. So that is our job. Okay, to make sure that our future generation can meet their own needs. So from there, in 2015, there is some revisit about the concept or the definition or the principle of the SD by Rachel from the International Florida Universities to emphasize that in practice, sustainable development require the integration, economic, environmental, and social objective across sectors. So the words integration, so meaning the need of these three pillars, what we call it, and in basic word is a component. To form a sustainable, it must be integrated. When we claim as integration, something that cannot miss. It's not be there. It's not combination, it's integration. So all these three is needed, then we can achieve the sustainability. Right. So that is a very so as we know that the three pillars of sustainability is come from the societies, environment, and economy. Society is referred to people, human, and in other words, we call it a social. Okay, environment or environmental, sometimes they call it economic. But if you look the models, okay, with the internet, we can see. We can see varieties of models that combine or integrate these three pillars. These three, for example, that I get from the image when I take the sustainability concept that is appear. So you can see what matters. What's wrong with that? As you can see, for these three, they put at the societies, they use the word environment, societies, economic. Healthy environment, vibrant economy, equitable societies. So this is the same thing, the only with the adjective or not. All these three, if you can see, they put the environment on the top. Okay, on the top, and have a look at the other one that I found. This is different. They put the environment, economic, social on the top. And on the left side, that is have a 4 circles, maybe to present that this should be integrated. They put that the environment at the bottom, and on the top is economic and social. Right, this that we found that this already different, and we can see another one as well. Environment, economic, social on the top. We have the social, ecological, and economic on the top. And on the right side is very rare. So, but they're still in the circle. So they put the environment as the big circle in the side that is society, and in the small one is the economy. I believe that there must be a reason behind this, why they put in such a way. Right. So, because when the United Nations delivers the statement of the meaning of sustainable development, they know such as a model clearly how it looks like. Okay. So now that with the internet that we can find. So our concern is about our generation. So which model that they should refer to. Of course, the 3 elements is there, but the concern is which one is the most appropriate that should be related with the current situation. Yeah. So, and in fact, whether it can remain, as the professors Yasselis mentioned about the resilience. So how this can be strengthen the model of sustainability. Right. So the issue is which one is the most appropriate in the era of this global crisis. Okay, let back the understanding when we present a model, so there must be a reason for each why we put on the left, on the top, at the bottom. So let's put these 3 elements in a circle. So when we claim it's integration, we agree that is must be connected each other. Okay, so if we can see these 3 components put in this way, okay, the condition of 1A is each component has integrated with each other to form the principles. That's the meaning. The second one, at the same time, the top component has affected by have been affected by the bottom component. That's the meaning that we can interpret from this model. Why we put in this such way? Because we also can put in this way. Okay, which means this can represent another meaning. Each component, the first 2A, each component has integrated with each other to form the same things, integrated. At the same time, the top component has affected by the bottom component. So 1 affect 2 compared to the previous one, that 2 affect to 1. Okay, now in the concept of the sustainability concept with these 3 pillars, so which one should be on the top, which one should be in the bottom? So that is my analysis in this case. All right, so it can be in this way as well. 3 components attached together, but there's different meanings. Okay, which is always the middle one is become the truss, and the left and right, but left and right is attached with the truss but not connected. It is. And this another model that we found just now, that normally that the meanings in this case, the outer component has been affected by the inner components. Meaning to have the outer one, we must have the inner component. All right. So like our body, to have the whole body's shape of a human, we have the component. So that's the very basic understanding of this. Right. Okay, now back to the sensibility pillar, the pillar of sensibility. So which is I use 3 different colors here so that we can differentiate, okay, the components. So I put blue for economy. Green environment is common when we talk green. It relates to environment, and kind of brown, this light brown is a social, it's like our skin, brown. So it's the people, human. All right. So we can have this. The first one is on the top is the economy, bottom is the environment and social. So the meaning is that social and environment, that the economy affected by the social and environment. Oh, should be in this way. The environment affected by social or economy. Or in this way, the social affected by environment or economy. Or in other words, we can say that the social support by environment, economy. Or we can put in this way, the socials that affect or support towards to environment and economy. Or this is in the case of the environment that support to social and economy. And this one, the economy support to, even though they attach, meaning that what I try to strengthen here is the key component that give the most effect to the other component or the other pillars. That's what my concern here. And or we still want to proceed with this model. Okay, which pillars that should be as a truss. Okay, so we could have 3 here if you want to be environmental as a truss models, or social, or the economy. Or we like to have this model. Okay, which one could be the outer, the result from the inner components. We would like to be that the final effect goes to environment, or goes to the economy, or goes to the social. So that is it. More than 8, but basically we have 4 different shapes that to describe the concept, the sustainability concept. Okay, a model, which means, of course, we are looking for the sustainable economy, sustainable environment, sustainable social. So when these 3 has been sustained, integrated together, so we have achieved what we mean by the sustainability. Okay? Right. So how to decide, how to recognize, what are the answer, which one is the most appropriate? We don't see that is, but in my personal opinion, what I can see, based on the description or the meaning of the arrangement just now, it couldn't be this way. Okay, because we know that human and economic, society, social and economy has interrelated, because economy is generated by the people, the society, so it's cannot be separate. And we also that knows that environmental and economy also has a relationships. When the environment is not stable, that affect the economy as well. And also we cannot put far economy and the environment and society, because we are living in this earth. Of course we have the effect, contribute some effect to the earth, so it cannot put it separately. So basically this the way of presentation of the model is not acceptable. It's just wrong. Okay, how about this one? This one as well, I have not really agree is present in this way, because there is because they are come in a parallels. We cannot, that is what is the ultimate effect of accessibility. We look at the outer circle. Okay, we cannot end up is an economy, or we cannot end up is a environment or social. Okay. Okay. This is let's go through the goals. Then we see later on what is the most appropriate model for this one. Okay, so we left 1 to 6, meaning the 3-1, the integration of the 3 ones. Because each one, back to this model, each one has a bigger aspect. So that's why we cannot put the bigger and smaller and smallest. This is sort of not, that is another justification why it shouldn't be put in this way. Right? So we left 1 to 6, which is either this way on the left, right, 2 support, 2 at the bottom, 1 on the top, or 2 on the top, 1 at the bottom, with the justification that I mentioned just now. Right. Okay. So in order to choose which one, so let's revisit the 17 SD goal or sustainable development goals, right? So that's been firmed by the United Nations. So they have 17. So here I highlighted in the dot there with the different color, that to reflect to this goal is reflect to sustainability of social or economy or environment. Okay, reflect to the color here. The brown is we have number 1, 2, 3, 4, 5 is reflect to the society or social. I'll go a bit details, not too details for each one. Meaning that what really happened currently reflects to the goals. Currently meaning that recent year after the pandemic. Right? Pandemic COVID-19, yes, I mean. And we have a grade number 6, 7, and the rest. Okay. So this is how that I relate these goals to which pillars. This goal when we have to achieve to ensure that is the sustainability of the pillars. Okay, right? Because it's been called as a pillar. The pillar has to be sustained, keep exist before we can have the whole sustainable. Right. Okay, we start with the social sustainability. Okay, social is refer to people or human only. It's not other living. Only people and human in this earth. Okay, so recently, what we know up to the September 22, do you know how many people in this world? So based on the US Cancer Bureau worlds, is about 7.9 billion now people in this world up to September 2020. And then they expected that they will reach 8 billion by mid-November. Yeah, it's close to 8 billion. So 8 billion is, can say crowded, quite crowded to our words. Okay. Right. Okay, that is all the, we have 7 goals related to the social sustainability or society, sustainable society. With number 1 is no poverty, 0 hunger, good health and well-being, quality education, gender equality, sustainable cities and communities, and peace, justice, and strong institution. Okay, so this is related to the sustainable society or social sustainability. Okay, have a look. What happened to this goal currently in the recently in after the pandemic? Okay, as well we can see, we know the first goal is no poverty. So if we cannot achieve this one, this will affect to the second goals, 0 hunger. Okay, and the second goal will affect to the third goals. If we don't achieve the first one and the first 2, bring to the good health and well-being, we cannot achieve as well. And of course, it will affect to the quality of education. So it's interrelated, this goal. So that's why they put that the first one as no poverty as the first one, to make sure people no 0, meaning no poverty is 0 poverty. When they have enough food, what was the we look at the poverty, what the meaning of poverty is here. They are referred to a person that lack of income, that to support their basic personal needs, food, shelter, and clothing, these 3 things. Okay, these 3 things basically. So if they cannot afford to have either these 3 things, that is very poor. But if they only afford food but cannot afford the shelter and clothing, also consider poor. But the target, the goal is no poverty. That's why it's not minimum poverty or reduce. They put no poverty. Okay, so the aim is end poverty in all its form everywhere. So that is the goals. Okay, so what happened now? Okay, recently, about 9.2% of the world is about 689 million people extremely poverty. Extreme meaning they could have nothing. Okay, so or they live only less than $1.9 a day, according to the World Bank. Unfortunately, this is previous COVID. The COVID-19 drove additional 97 million people more go to the extreme poverty, because we know that the activity is freezing, the economy is freezing. So the first goal is now, after 33 years, it still cannot achieve. It's our concern. Okay, right. What happened? This is the recent poverty rate in 2020. So we can see that the underdeveloped countries shows the highest, normal like Africa, okay, and what the red color you can see, it's still there. Okay, it's more than 100 years after the launch of SD goals, 33 years. There's no such as a change in this case, right? All right, so we go to that zero hunger. Okay, at least zero hunger. If we meaning that everybody can have their own food. So the aim is end hunger, achieve food security, and improve nutrition and promote sustainable agriculture. So not only hunger, the food securities and the nutrition, okay, to the people. That is the second goal. That of course is direct to the society, the sustainable of the society. Okay, what happened? Recently, in 2021, global hunger numbers rose to as many 828 million. Rose. More hunger that we had. So by the WHO, World Health Organization. So it's another bad news. Right. And the third one, good health and well-being. The aim is ensure healthy life, promotes well-being for all ages. Okay. So what happened? So the recent the WHO statistic in 2020 about when we talk about health, of course, it's related to the disease. As we know, the COVID-19 now is still around. So yeah, we recover slowly. And what they share in the report recently, they're still pleased that the people that haven't got the full vaccination. Okay, so this is the statistic. The person fully vaccinated with the last dose. Okay, it depends on the country. With of course, that basically we have to have the 2 doses. So that we can see that these countries, there is places that haven't received that. And what else that we have about the communicable disease? Communicable disease is the disease that easily transfers through the within the people. Okay, so malaria is still the concern here. Okay, so sorry, not malaria, here is a HIV. Okay, 1.5 million people acquired HIV for the first time in 2020. 1.5 million. And globally, new HIV infection on 2020 were 40, even though it's lower a bit than 2000, but still okay. However, no region has achieved the target. Yes, this is reduced. Okay, but there is a target for the statistic for the HIV, which is the 70% reduction of new infection by 2020. This target has not been achieved yet, but this is for this good this part that is positive result, meaning that they reduce but still not achieved. But the progress is good for the HIV case. Right. And I just choose put the top one. That is in the report there's so many diseases, but of course I don't have much time towards that. So then they have the estimate numbers malaria in 2020. So reduction as well, 27% reduction in global case, and almost 50% reduction of global malaria mortality, meaning the deaths, meaning that they improve the treatment for the malaria, which is they can reduce the 50% reduction of mortality. It's a big achievement in this case for the malaria. This is the positive progress in terms of, but in fact of that, we are now facing a bigger disease, that is COVID-19. Okay, right. There's another part is about the neglected tropical disease, okay, which is involve 1.73 billion, not million, related to the neglected tropical disease. The country that in a tropical condition that they have the kind of disease, okay. Which is, however, that is fewer than the compared to 2010. 2010 is about 2.91 billion. So it's reduced. It's a good progress as well. Okay. That's about the health. Okay, but our biggest challenge right now is about to handle the COVID-19. Okay. I didn't go for the education yet. Because that will be put in my conclusion later. So for the gender equality, the aim is women and men, girls and boys enjoy the same right, resource, opportunities and protection. So this is another goals to achieve the social society sustainability. What happened? So from the recent report from UNICEF, still occurred 13 million numbers of adolescent girls 15 to 19 that experience forced sex in their lifetime. Still happening. And the rate of homicide among adolescent boys compared to adolescent girls 4 times higher, boys more to homicide. Okay, still occurred. And in terms of education, so we can see that here girls more out of school rate among the girls compared to boys, especially for the for the worlds, we can see that the ratio is 9 to 7 globally. The girls that out of school rate. Okay. And this is by country, but here I think the developing countries like American, North Africa, and so on. So that's the figures. Actually, they put by region. Okay, but still that shows that the girls have more girls that got out of the school rate, especially for the primary school. Okay. All right. And in terms of the unpaid work, okay, so the girls aged 5 to 14 spend 160 million more hours every day, meaning girls more works more time than unpaid care and domestic work, because they are considered in the unpaid care and domestic work than boys for the same age. Okay. Still occurred. And the second line is reduce inequality. This is ensuring no one is left behind across gender, across race, of country and region. Equality. Okay. So there is some report. Okay. That relate to this. No one is left behind. We can see since the pandemic, the treatment, vaccination, and refugees, and so on. So that is you can see still occurred. Still, the statistic is still is not in good way. All right, and I have to speed up my presentation. So this is about the digital divide as well. So the people in rural, so they're left behind the technologies compared to the urban. Right. And the last one is related to the social, is about the sustainable cities and communities. Make cities and human settlement inclusive, safe, resilient, and accessible. Safe, resilient, and sustainable. So what happened in terms of the housing, transportation? This is about the urban people. What happened? So that's we can see that in 1991 taken. In Turkmenistan, for me, a Soviet Union country, there's the abandon of the city, the marble building. So that's been referred as the city of the dead. So you develop, but it's just abandoned. And recently, the conflict goes down a lot in China. Okay, so it's related to economy as well. So the building without people, and complete building and so on, right? Okay. So in the transportation, we are still facing the traffic, and we solve with the another type of transportation, train, subway, still congested with the people. And in India also is the scenario is sustainable. Okay, congested. So haven't been solved yet. And this is resilient of the urban when that is impacted by the flood. Okay, the environment. So due to that, the development of the urban itself, if you can see, 85% of the world urban settlement have ground. 80% at the area that near to that underwater, that easy to get flood. That the things. Okay, so since 1985, about 76K newly urbanized landed location under that is can result. So this is the planning of the cities itself. It's not bring to the future generation for the better, for the future. That's the thing. All right, and the last one is the aims to promote peaceful and inclusive societies for sustainable development. So what happened in this case? The peace and justice and strong institution. So what we are facing now. Unfortunately, they realized in this case, in that time, the UN realized that conflict, insecurity, weak institution, limited access to justice remain a great threat to sustainable development. Why? Because we can see the conflict, promote peacefully. So that is the death rate from conflict and terrorism in 2019. So that is they monitor the area. They still actively have the conflict and terrorism in this area in 2019. Okay, so that is the cause of deaths. Okay, for that particular. And recently in 2020, so we know that we see that this is additional area that have a conflict. Russia war between Russia and Ukraine that is still going on since February this year. Okay, so where's the promote peaceful? It is still cannot achieve. It's more and more. We can see that, right? And because of that, of course, a lot of the statistic of refugees is rose recently in 2021. So nearly 100 million refugees cause of this conflict. Okay, so that's about the social or society sustainability, the goals, so we go to the environment aspect, sustainability of the environment, or sustainable environment, environmental sustainability is all about the same thing. Okay, first of all, we have to know how old the earth that we are living now. Okay, so I look from the trusted resource here that they claim that is from the National Geographic, of course. Okay. It's 4.54 billion years. That is the estimate year olds of our Earth that we are living now. It's getting older and older. Okay, so that's why what we're facing now, there's two situations that the disease that our Earth have currently, they are not well now. I can say that is sick because of their own body itself getting older, and because of the effect of others external entity, especially the people or the human living in this body. Okay, so
Professor Zuria,
yes.
Apologize for the interruption, but the time for you is almost up, please. Yes.
Okay, so what should I do? So I skip to the conclusion, or? All right. So, okay, regarding about the environmental, that is the aims is about the clean waters. So we can see still facing problem about the drinking waters. Okay, 2 billion people still use the contaminated drinking waters, and issues on the clean waters. We can see it's also from the Africas. Okay. And the Second Nation as well is still we are facing a problem. 4.2 billion people use safety. This is only half, 50% only that have a safety managed sanitation service. And climate action, take urgent action to combat climate change. Okay, so we know that global warming is the old issues from long time ago. Seems like our is melting. And this is the temperature, how hot it is across the area in the world based on the recently September. You can see the hotspot. Okay, and that is the result of this global warming mega drop. Okay, in West America, and we have a massive flood. Okay, recently we know that's Pakistan, massive, only left about few land for them to stay. And we have a landslide in Nepal, the worst last year, and wildfire is still going on. Okay, South Turkey and California is damaged a lot, and we can refer to the wildfire currently. That is I have from the last 2 days from NASA satellite still occurred. And the same date last year, so nothing changed. It's sustainable, it's sustained. Okay, the fire, and it's during the summer, August. We can see that it's more, and that is the storm as well, hurricane. There's so many types. It's massive damage, and the statistic that is sent by the Colorado State University recently. So she that the measure into the days of the storm is they have a category of the name storm days, so up to 400 days, more than 1 year, meaning every day have to occur this having the storm, and also the hurricane. You can see that the reduction, but the increment in the storm the days, right? So that the fish, you can see the many cases in Japan, in Europe, okay, so across the world. And this matter, the global fish stock, okay, 2 years ago that they concerned about this. And the land Okay, so the living in the land, not only human. So from the microbacteria until the thing that we can see, elephant. Okay, so we have a 2.13 million species of group. So this, but what matters here is that when come to life on the land, we with the plant, with the animals here, we are sharing the land, oxygen, water. But we know that the plant and the animal, they are vulnerable. So we are the people that can manage all these things. So that's the points there. And I very quick review to the economy part. So we have it's about the buying power, basically, that we use the money. So in the notes and the shillings that we in different currency in different countries, then which is this is trade in occurred in the local or across the international. So that is the goal for the economy, basically, right? I don't go in detail, but what I like to highlight here, the last one, is about these three things. So you see the effect. Basically, the society or the people, they obviously they give effect to the environmental, okay, with the activities, and of course that the society also that develop the economy, and the environmental also, the earth we refer that also give effect to the society when they are getting older, and a lot of happen. So this is what we can see behind the earth also effect when it happen, effect to the economy. So this is what we can see the relationship. Obviously, basically, is what we have. And so from here that I would like to affirm that the appropriate model for the sustainability, the global axis is should be in this way. Okay, meaning that social and environmental should be at the bottom, which is they bring to the economic. The economic should be on the top. Okay, but what I like to highlight here is how far that we need to go to have a back, okay, sustainable. So of course that so many innovation that has been presented before, the ideas, let's proceed, but never forget. I agree with Prof. Yasserli that it's all about human, because we are the human that the one that do the activities, do the intuitive, to do the things, to plan, to deliver, and it's about the social. So what my point here is about the education to the people to understand how much we can contribute to sustainability of our economy, environment, and economy. Starting from the small individuals, families, organization, country, and so on. What one of the slide from the Prof. Yasserli just now is a very good slide. Meaning it must start from the individual itself, the awareness for us to contribute to the sustainability of the economy, environmental, and bring up to bigger society. So I'm so sorry to take so much time. So that's all for me for this keynote. Thank you.
Thank you for your presentation, Professor Dr. Zuria Binti Ibrahim. Such a beautiful presentation and give us so much knowledge. And this is the certificate of appreciation for you, Professor.
I don't know how to unshare.
Please, Professor, can unshare the share screen Zoom?
Yes, I like to how to, because I'm not really familiar with the.
Yeah, it's okay.
You can help me to unshare, because normally we use we use Webex or Microsoft Teams. Is it done?
Yeah, it is done.
Okay, once again, this is the certificate from us for you, Professor, for appreciation from us.
Okay, thank you so much to the organizer.
Okay, thank you, Professor, and hope we can meet again and have a nice day.
Thank you so much.
Okay, before we next to our next keynote speakers, let me mention the presentation from all keynote speakers will be uploaded and we will send the links to your email. Next, our keynote speaker from Kyoto University, Japan, Professor Benjamin McClellan, who an expertise on sustainability within the energy and resource sector.
Okay, for Professor Benjamin, can you hear us?
Yes, thank you.
Okay. Once again, I'm such an honor to represent Professor to this international conference. And
Professor, are you ready to share your keynote speech for us?
Absolutely.
okay,
Please welcome Professor Benjamin McClellan. The time is yours.
Okay, thank you very much. Just let me say thank you to the organizers for inviting me. I'm very happy to be here. I will endeavor to keep this relatively short. I have entitled this Resilience and Resources for Just Sustainable Energy Transitions, hoping to keep it somewhat within the idea of the conference. So just as a very brief introduction, I think many people are aware, of course, but we are living in a world where we're trying to transition because it's vital for achieving climate change targets. However, the pandemic, of course, brought us some short-lived reduction in energy consumption because people couldn't travel as much. It differed in different parts of the world, how much impact there was, but basically there was generally some impact. But also many governments, noting that we've had a significant economic downturn, have been focusing on resilient systems and investment in green post-pandemic recoveries, including a lot to do with renewable energy. At the same time, many countries over the past couple of years have, more than 130 countries have set targets for achieving carbon neutrality. So what does this mean, all of this, as we transition for energy, for the resources that we require for energy systems and for people? So firstly, just a note about carbon neutrality. So most, again, many countries, more than 130 countries have been aiming to or have set targets for carbon neutrality or net zero emissions. This basically means that emissions of greenhouse gases should be balanced by absorption and removal so that overall they come to zero. So we could see that, for example, here, I think this is an example of the IEA's net zero emission scenarios. We have some combustion activities, but these are linked with a reduction in or a removal of emissions, so that ultimately it adds up to be net zero. Partly because it is seen to be quite difficult to achieve a total zero emissions. So to achieve carbon neutrality requires an energy shift plus this emissions removal. Now, there could be many options for achieving zero emissions, but basically we'll be looking at some energy supply system that would have a mix of different zero emissions technologies. You can see, again, this is for an example from the IEA's World Energy Outlook from 2021. We can see that they have a significant, estimate a significant reduction in fossil fuels, unabated fossil fuels, which is the black bar there, whilst increasing significantly all of these other forms of of non-emitting technologies. We can note significantly that there is an expectation of a massive increase in solar and wind by about 20 times, and in fossil fuels with CCUS more than 100 times, but that carbon capture, utilization and storage, but that's from such a low base, which is why it's 140 times. But all of these other forms of energy of different renewables expecting to increase quite significantly, while unabated fossil fuels drops to a very low factor of what it is at the moment. But in any case, there's a very significant increase in renewable energy required. So there are a variety of different technologies also on the demand side that we require. So these are technologies which are required to increase the efficiency of energy consumption and to enable electrification, which is where most of the renewable energy technologies are focused on. So we want to utilize low or zero carbon fuels, which could be renewable electricity, or it could be hydrogen or biofuels. And you can see here again within these the IEA scenarios, one example of a mix including a lot of electricity in transportation as well as hydrogen and other fuels. So the point is basically there are a lot of initiatives across the world which are focused on electrification of transport. Many of the major markets, I think including India, Japan, and other parts of the world, have determined that they want to increase dramatically the amount of electrified transport. And electrification of transport, so EVs, electric vehicles, is potentially one way of helping to store or to balance variable renewable energy that we have in the form of solar and wind, which we know produce power basically only when the wind is blowing or the sun is shining. But in order to do this, and this may seem a little bit out of left field, in order to do this, we need a lot of resources. So we can think of a variety of different resources, and I will focus on minerals here, just because it is part of my expertise. But there are bulk minerals. So in order to install all of this new infrastructure, we're going to need a lot of different bulk minerals, those which are critical for infrastructure. So this is iron and steel and cement. And these sectors are also critical for emissions reduction. So at the moment, iron and steel and cement together are a very significant part of global emissions. Probably somewhere around 15 to 20% at least of global emissions is from the iron and steel, the production of iron and steel, and the production of cement. So they have we need to think about options for improving or reducing emissions from these technologies. So that means decoupling these emissions from energy and from production using innovative technologies, which might include using hydrogen to produce iron or CCS. But these bulk technologies are not what we would typically refer to as critical. So critical minerals have become more interesting over the last 15 years or so in particular. And there are a number of different methodologies out there for assessing what critical means. But basically, we have a couple of factors. One, so a material can be regarded as critical only if it performs an essential function for which few or satisfactory substitutes exist. And there is a high probability that its supply may become restricted, leading to physical unavailability or significantly higher prices in key applications. So basically, there's an aspect of supply risk as well as economic importance. So when we talk about critical minerals, there's also environmental implications to think about. But when we talk about critical minerals, we're talking about mostly minerals which have a key function in a technology, but are generally smaller in their size of their markets. In energy, some of the most relevant technologies are solar PV and wind turbines, batteries for energy storage and for transport, fuel cells and electrolyzers to make green hydrogen, and in transmission and distribution systems, as well as a variety of other options. Some of the metals that are of interest are things like platinum group metals, platinum, palladium, etc., cobalt for use in batteries, graphite, rare earths, and lithium. Now, when we look across various minerals, this is some of the data about the geological reserves of minerals reported as the R/P, the reserves to production ratio, which basically tells us how many years worth of these materials we have at current production rates. So these are some of our common metal resources. You can see bauxite, copper, iron ore, lead or zinc, ranging between say 20 to about 80 years worth of availability. Whereas some of our energy minerals of concern, some of the ones we think of as critical, actually have much more availability. So things like lithium, there's 250 years of known reserves. For something like rare earths, we're looking at more than 500. So there are a lot of we can't just think of how much of a material there is. That doesn't tell us everything about resource security. Now, electric vehicles as one of these key technologies, again, are quite important, and we see this. So electric vehicles, in electric vehicles, we have a requirement for magnets, generally for use in electric motors. And these tend to include things like rare earths and cobalt. The batteries tend to be, these days, lithium-ion batteries because they are light and they are effective. So we have lithium, graphite, cobalt, nickel, manganese, and of course there's a lot of electric wiring that goes into these vehicles. So the battery capacity is expected in electric vehicles to expand by around about 200 times under the IEA scenarios. And that means that there's a significant requirement for these new materials to expand. So electric vehicles, again, typically using lithium-ion batteries. There are many batteries being considered as alternatives, but basically these are the best that we have at the moment. Around about 74% is estimated to be used of lithium produced globally is now used in batteries, as opposed to around about 19% in 2007. So in 15 years, the market for lithium in batteries, or the percentage that's used in batteries, has massively grown within the market, within the total market. Now, lithium reserves contain more than 200 years worth of lithium production, and there are many more in terms of resources, which is less economic or less certain. But there's a relatively high concentration of both production and of reserves. So most of the countries producing, so in terms of lithium production, Australia and Chile are the two largest producers. And in terms of reserves, Chile and Australia, although there is much known available resource in Argentina and Bolivia. But these producing countries are relatively low risk. So in the sense that they are unlikely to cut off supply. So lithium, though, is not the main issue. So for most people, when they think of lithium-ion batteries, or they think of what the important minerals are, they think lithium. Obviously, it's in the name, but lithium is not really the main concern. Actually, there are more concerns about some of the materials that we use for the electrodes within those batteries. So things like cobalt, nickel, and manganese. These are more rare or more critical, as we would call it. So there are issues also of environmental impact. So the water use for lithium extraction from brines, which is the main extraction process in Chile, is quite extensive. And there are also some social political issues, so around conflict minerals in the Democratic Republic of Congo, So there's a question of whether we can handle or produce a 15 to 20-fold increase in resource requirement with no technological improvement. There are a few examples here of the geopolitical risk associated with some of these minerals, so cobalt and lithium in Japan and Europe. Now, one thing to note is that non-fuel minerals, so in this energy transition, these non-fuel minerals that I've talked about are becoming much more, they're becoming much more important as we move from basically from fossil fuels through to metal-based technologies. And these technologies, these metals are becoming much more, or they are much more geopolitically risky. So you can see here on the left the production the production concentration of fossil fuels as represented by the HHI, the Herfindahl-Hirschman index, and on the right is the concentration for the various raw materials used in batteries. You can see that it's notable that coal, oil, and gas are relatively geopolitically or geopolitically dispersed, or they are not as concentrated as are some of these metals, which is a very interesting factor. There are also various issues of development and political stability. So again, fossil fuels are are widely distributed on the whole, and the energy mix of each country, though, is an important influence. So self-sufficiency is often considered an important factor. Let me skip over this, though, for a moment. Let's move to hydrogen. So hydrogen has been you probably hear about hydrogen a lot. There's a lot of excitement about hydrogen at the moment. And this is one of the multiple waves of interest in hydrogen. Hydrogen was of interest about 15 or 20 years ago, for those of you who are old enough to remember. But there is a high uncertainty about the potential for cost reduction in hydrogen supply chains. There is a need for at least a 6 times increase in production by 2050, and that's if we're only producing a relatively small amount of hydrogen for energy purposes. So that's quite a significant increase. Most of the, you may not know, but most of the hydrogen that's produced at the moment is produced from fossil fuels, from oil and gas. And so this idea of green hydrogen will actually require a lot more platinum group metals, rare earths potentially, and other metals which we'll use in fuel cells and also in electrolyzers, as well as potential materials such as palladium or vanadium for purification. And many of these metals, particularly the platinum group metals, are very critical. They're highly concentrated, particularly for platinum group metals in South Africa and in Russia. But so there is a real need to improve technology in order to make this possible. So electrolysis technology is basically the same as fuel cell technologies. In the IEA scenarios, you can see down on the right-hand side what the expectation of where this hydrogen is going to be coming from. Basically, they expect that a lot of it will be from electrolysis through more renewable energy, but also they have this remaining component of basically fossil fuels with CCUS. So we need to reduce costs through scale up and innovation. Otherwise, hydrogen is unlikely to contribute significantly. And that is, it's a bit of a chicken and egg problem. So as it has been for a while, when we don't have enough demand to invest in infrastructure, therefore we don't invest in infrastructure. If we don't invest in infrastructure, the costs won't come down, so the demand won't be there. Things like solar photovoltaics also have a significant number of critical minerals. I'm just going to put these in here just for very briefly. But if we're looking, and this is a focus on the Asian area in particular, you can see that there's ASEAN, China, and India listed in there as three big groupings of countries within Asia, big countries or groupings of countries. But basically, if we want to achieve some of the targets for PV, then we're going to need to increase production much further, so that the green line in each of these is 2016 production, meaning that we need to increase production many, many times in order to be able to achieve in just of these raw materials, in order to be able to achieve the potential for this solar-based future. And wind power has similar issues. So for wind power, we tend to use, in some of the best wind turbines, we're using very good permanent magnets, which use neodymium and dysprosium, which are both rare earths. There are a variety of other factors to think about when we think about resources, particularly mineral resources. There are various other minerals which are used for nuclear or for other technologies. There are also various ways to improve emissions from the full production cycle, particularly through options with circular economy, for example, of reuse, regeneration, and recycling. And then there is deep sea mining, which has a vast resource, but an uncertain economic and environmental impact. However, we also need to think about other aspects, so non-direct impacts, or non-carbon impacts. If we need to dig more copper out, that means there's going to be more releases of copper compounds to the atmosphere, more arsenic, because it tends to be associated with many of these copper compounds. So if we want to, we need to think also of these localized impacts, which are very likely to increase. There's also a potential that the total material requirement, or the indirect impacts associated with both electricity and transport, will increase due to the requirement for minerals. So the waste materials associated with the production of energy and the use of energy will increase. And where will these impacts be? We will expect these impacts to transfer from places which are currently producing fossil fuels through to places which maybe will be producing new metals. Now, just to finish up, I want to briefly mention this idea of a just transition. So when we think about these localized impacts, it's very important to think about who's actually going to be impacted. So when we think about these type of transitions, people who work in coal-fired power stations will lose their jobs if we shut down the coal-fired power stations. But will there be opportunities for them? And we would expect there would be opportunities in the renewable energy sector for these people to take up jobs. Now, what should we be thinking about in terms of, or what is an important priority for these energy transitions? We have looked at this in Japan, and for Japan, the idea of fairness for all, or making sure that everybody has a chance, is actually not considered to be quite so significant in terms of the priorities. The highest priorities are about the environment and about energy security. And let me just skip over this, just to note that likewise, those in Japan would highlight that we need to think about children and the next generation when we think about our energy planning, which is something which is quite important. I'm also going to skip over this, though it's quite interesting, but to say that we do need to consider the social impacts and the localized environmental impacts which have flow-on social impacts when we think about these transitions. So just these concluding remarks then. There are many uncertainties about these transitions. There are many particular options, and that flows on to availability of resources. And I've talked mostly about mineral resources here, but it also flows on to things like costs and technology. Can we substitute for alternative technologies? Likewise, we need to consider this idea of a just energy transition for the communities which host mining and also the communities which host power stations, as well as the flow-on effects. So if the electricity costs too much, then it's also going to be an impact. There are a variety of opportunities. There are also synergies and trade-offs. So I will leave it there, and thank you again for the invitation.
Keynote speech from Professor Ian Campbell from Loughborough University, United Kingdom. Professor Ian Campbell have an expertise on additive manufacturing and practice product design.
Okay, hello, Professor Ian Campbell. Can you hear us? Hello, Professor.
Okay.
Okay, wait a second, yeah, for all participants. Maybe the Professor Ian Campbell have another unstable connection.
Okay. He's
Hello, can you hear me now?
Yes, yes, Professor, I can hear you. Okay. Okay, Professor, are you ready to share your keynote speech for today's presentation?
Yes, I am. Thank you.
Okay, please welcome Professor Ian Campbell. The time is yours.
Well, hello everyone, and thank you very much for this opportunity to share some thoughts with you. I hope the conference is going well, and I'm sorry I can't be there in person. I'd like to talk this morning about the role that additive manufacturing can have in helping to develop robust and sustainable supply chains. So the background to this is that we saw during the COVID-19 pandemic and during recent events in Ukraine that the current industrial ecosystem we have is very prone to disruptions. And that can have a major impact on world trade and also in terms of the manufacturing industry. So we see that manufacturing has been interrupted in various parts of the world. Supply chains have become unreliable compared to what they were previously. And also we see that the cost of transportation has been increasing, partly due to the increase in demand there's been and reduction in supply, but also because of increased fuel costs. And the whole result of this can be that our products can be more expensive to get to market, and we may not be able to keep up with demand. So for example, at the moment we see in the automotive industry, some models are having great difficulty being produced because there are not enough chips to put into those vehicles. So the question I'm asking is, how can additive manufacturing, which I'll refer to from now on as AM, how can it help companies inject robustness and sustainability into their supply chains? And we're going to look at several ways this can happen. One is that manufacturing can be localized in the short term to overcome supply chain disruption. And we'll see how that can happen relatively easily. Then we'll look at what some people call onshoring. And that is where parts that had previously been made overseas are once again made closer to the manufacturing or the assembly plant. And this is really aimed at trying to overcome some longer term supply chain issues. And then thirdly, we'll have a look at quite a new concept or a radical concept of what is sometimes called point of sale manufacturing, which is really trying to do away with the supply chain altogether, or certainly to minimize it. And then we'll see that additive manufacturing does have a contribution to make towards sustainability in terms of reducing, reusing, and recycling. So this is what we'll go through. I'll give a short overview of additive manufacturing, not really how it works. I'm afraid I'm kind of assuming that most people know how we can add materials to make parts. But really, I'll be talking more about the benefits it can bring. Then we'll have a look at localized manufacturing. We'll have a look at onshoring of manufacturing, point of sale manufacturing, then reducing, reusing, and recycling. And finally, we'll draw some conclusions. So first of all, in terms of giving an overview of additive manufacturing, here are some products that have been produced using various types of additive manufacturing, both polymer and metal AM. And what we see is AM does offer flexibility in producing a wide range of designs. It's very capable at producing complex shapes, as we can see from some of those images. It doesn't require the time-consuming aspect of manufacturing tools. In a way, you could say it's a tool-free manufacturing process. So that means that parts can be made almost as soon as the computer-aided design model is completed. Therefore, it can facilitate just-in-time manufacturing, and that can be done even to producing, if we wanted to, one part at a time, although that would not be economically feasible. It can produce more efficient products because of the shapes we can create. We can make our products more streamlined, for example, and we'll see some examples of that. It can also produce customized products, which can help us to increase the value of the products that we produce. So if additive manufacturing can do these things, then we need to think how it can help with some of our short-term supply chain disruptions. And if we think of the things which can affect our supply chain, then some of them we've had very good examples of, or should I say very bad examples of, quite recently. So parts can get delayed in customs, so whereas we might want a daily delivery of parts, then, for example, what's happening with Brexit at the moment, because the UK has left the European Union, we can no longer guarantee that parts will get through customs quickly. And as a result, there can be delays in deliveries. There can be shipping or transport delays. For example, we saw during the blockage of the Suez Canal by a large container ship that there was severe disruption to the shipping transportation from the Far East into Europe. And then, of course, we can see sometimes there can be temporary shutdown of overseas or indeed a local manufacturing. So, for example, during COVID-19 lockdowns in Shanghai, some manufacturers were not able to continue with their manufacturing process. And that, of course, will impact the supply chain significantly. And you can probably think of other things which can affect our supply chain quite dramatically. And it'd be great if we could try to look into the future and guess what these might be, but really we don't have a clue. But what we are saying is that the interconnected system we have at the moment is indeed quite fragile. And so we need to try and make it more robust. So what would be potential solutions that a manufacturer could look at to try and bring in a bit more flexibility or robustness into their supply chain? Well, one thing, and this is being done in the UK now, is people are building large warehouses to hold more stock. So rather than having to rely on just-in-time deliveries, they can draw down parts from a warehouse somewhere in the UK. Of course, it's very, very expensive, both to build those warehouses and the cost of running them. So that will add expense to our product. Instead of relying on one supplier in one part of the world, perhaps we can have different alternative suppliers in different parts of the world. This will bring in an administrative overhead to the company because of maybe a lack of economies of scale. It will also result in more inefficient and therefore more costly manufacture by those individual suppliers. And then we have the choice of trying to what some people are calling onshoring or bringing parts in-house. So rather than having our parts made externally, we use conventional manufacturing to make parts, maybe not in the long term, but in the short term. But of course, that requires tooling setup. And then the production rate might be variable because we can't trust exactly when our parts are going to, from our suppliers are going to be delivered. And very often, especially in Europe, producing these parts in-house is more expensive than having them produced overseas. So all of those are available, but in terms of short-term solutions, we're going to look first of all at how AM can help us to make parts on demand. That is, to fill orders when our bought-in parts from suppliers are not available. So it's not a permanent solution, it's a way of trying to plug the gap in our supply chain. So one way this could be done is to use AM for what some people call direct manufacturing, that is the production of end-use parts. And AM indeed can make parts in a wide range of materials, especially in metals and polymers. They have the accuracy and surface finish quite similar to what is achieved through the casting process. And so for some applications, AM can be used on its own. Production volumes can be varied quite easily to suit demand. You can decide exactly how many parts you want to put through your AM machine. And you can either have this done in-house or you can outsource it to an AM service provider. So here's just a little example of some metal parts that are being produced using AM. And you can see there that it can be used for quite, for small parts anyway, it can be used for quite high volume manufacturing. But more often it is being used for a smaller number of parts. Now, a very good example of when this started to happen was during the COVID-19 pandemic, where what we saw in response to a shortage of medical equipment and personal protection equipment, many companies and indeed universities as well switched their AM machines to producing this equipment, if you like, on an emergency basis. And some examples of this were various tubes and valves. This one here, they were used to convert a snorkeling mask into assisted breathing apparatus. Here we see there was a shortage of respirator valves, and so these were produced using a polymer additive manufacturing machine. People wanted face shields, and so it was quite easy to make these sort of plastic metal clips, you could call them, or frames, and to insert perspex in them to make face shields. And also people were making nasal swabs. And here is an example of a batch of nasal swabs that was produced using the stereolithography type of additive manufacturing process. And you may be aware of other examples where, if you like, the short-term shortages of these materials and parts were filled in with additive manufacturing until production using conventional processes could be stepped up, or until supply chains were re-established. And this opened a lot of people's eyes to the potential of additive manufacturing to be used in this way. However, there is quite a major problem with additive manufacturing, in that the range of materials that is available is not as wide as that would be available for conventional processes. And sometimes we need a greater accuracy or a better surface finish than what additive manufacturing can provide. And if that's the case, then direct manufacture using additive manufacturing will not do what we need. So in these cases, what we can do is to combine AM with other processes. And I'll just show some examples of that. So again, if we're looking at short term, then we can do something called bridge tooling. It's where we use polymer AM to make a soft tool that can produce a limited number of parts, but can be used to fill gaps in our production schedule. It can be produced very quickly and at relatively low cost compared to conventional tooling. And here are some examples of tools that were made in a polymer aluminium combination, and the parts that were produced from them were little plastic parts to house electrical meters. And there's the electrical meters that were produced, the parts that were produced, and the assembly of the meter. And in this case, the company used these tools to get their production running more quickly before the mainstream tools came into use. Hybrid tooling is another way we can use AM. This time we use metal AM, and we produce tooling inserts that can then be fitted into a standard steel tool bolster or surround. These can be used to produce many parts, in some cases as many parts as conventional tooling. But they're still quicker to produce, not as quick as polymer, but quicker. Here we see an example. Inside the main bolster, we see some tools that have been produced with AM, as well as producing the tools with AM. There has been a finish machining operation, but still they are quicker to produce than conventional tooling. And here are some of the products that were produced from those tools. Once again, the idea would be that we could use this for a smaller batch production, which might be sufficient for some products, but again, would be enough to keep us going until the main metal tools come on stream. And so if we had a break in production, or sorry, a break in supply, where our parts were not coming from an overseas injection molder, for example, we could set up a localized injection molding process using tools produced with AM. Another thing we can do with AM is to produce patterns that can be used in the casting process. So here at the bottom, we see a polymer part that was used in investment casting to produce the aluminium part that we see alongside. And we can also, that was quite a large part, we can do it for small parts. This is a kind of wax pattern that was made using AM. We see that in green, and that has been used in investment casting to create some silver jewelry. And casting, sand casting can also be used with AM patterns. And so it is possible to reproduce conventional casting processes. So that's what can be done in the short term, where what we're really trying to do is to replace temporarily parts that would be normally produced using conventional processes, maybe injection molding or maybe casting. And that's fine on a short-term basis, but there are issues with AM, which mean that in the longer term, that would be a very expensive way to continue production. However, some companies are currently looking at what they call onshoring of manufacturing. And one reason they're doing this is to overcome some of the longer term supply chain issues that they are seeing. Examples of these longer term supply chain issues include inadequate quality or delivery reliability. So it might be your suppliers are letting you down in some way, and you feel that you need to bring production closer to home, so perhaps you can have better control over it. It may be that you're seeing some of your intellectual property being misused by your suppliers, and again, that's something that you have some very valuable parts where you want to protect the intellectual property, so you keep that closer to home. In some cases, government sanctions have been placed on various countries around the world, which might mean that your suppliers you have been using in the past are no longer available to you. It might be that you've seen a large increase in transportation costs, which has made importing from overseas economically unfeasible, and therefore you want to bring it closer to home. So if any of these are happening to a company, and it's not just a short-term problem, it's something they see as long-term and they want to change their supply chain permanently, then again, how can AM help in this way? Well, we could use the solutions already shown for that have been used for short-term supply chain correction, if you like, but the issues with that is AM is typically more expensive than conventional manufacturing if you're simply using it to create the same part design. And we'll see how that works in a graph shortly. Therefore, typically AM at the moment only makes sense for relatively low volume manufacturing, except for very small parts, in which case you can go higher. Ways that we can increase this, or ways we can overcome this really, is that we have to produce products where AM is used to increase the product value. So you're no longer making the same parts as were made with conventional manufacturing. You're somehow making the parts either cheaper, or you're improving their value so that people will pay a higher price. Now, in terms of AM part cost, just to explain this, for most shapes and production volumes, AM is more expensive than conventional processes such as injection molding. The exceptions are low production volumes, and if we therefore do a like-for-like part level cost comparison, we see this type of graph, where with additive manufacturing, the cost of production is relatively flat, no matter how many parts we make. So whether we make 10 parts, 100 parts, 1,000 parts, 10,000 parts, there is some reduction in cost, but not great. Whereas with something like injection molding, because there is a high cost of tooling, the more parts we make, then the price per part reduces quite dramatically, because the tooling cost is spread over a higher production. And so in terms of break even, what that tells us normally is additive manufacturing is cheaper if we're trying to do a small number of components, but more expensive if we're trying to do a large number of components. And so like for like replacement really only works if your production volumes are small. However, what we need to do then is see, okay, how can we increase the value of our parts with AM, either by reducing their cost in some way, or by increasing the price that customers will pay. So let's look at some ways we can do that. So one way we can do this is trying to reduce our overhead costs, and something which AM has proved itself to be very good at is producing highly complex, multifunctional, sometimes even multi-material components. And therefore we can reduce the number of components in our products, cheaper assembly, cheaper storage costs, and cheaper administration. So here's an example from 3D Systems, where on the left, we see an exhaust system with many parts in it, which all had to be assembled together. However, with AM, that could all be reduced to one part. And especially the aerospace industry, and to some extent the automotive industry, are using this to great effect, where they're changing multi-component assemblies into single part systems. And the reduction in overhead costs can be dramatic. We're also seeing that because of the complex shapes that AM can produce, then we are seeing more efficient parts being manufactured because we can optimize the shape. So for example, internal flow channels. And here's a very nice example from FitWest of a single cylinder combustion chamber, where I hope you can see the channels for oil and water and so on inside the combustion chamber that have been optimized for more efficient cooling and more efficient flow of the oil. And that means that the cylinder head itself can be produced with less material, but the engine will be much more efficient. And if you have a more efficient engine, hopefully you can sell it at a higher price because it will have lower running costs to your customers. We can improve product ergonomics. AM again can produce quite nice complex shapes, and we can therefore optimize, for example, the fit of a product to our customers, or in this case, it's an optimized grip geometry for a tennis racket. And so the tennis racket handle has been given quite a complex shape, but this gives improved grip for the user. And again, you're hoping therefore you can charge a higher price for that product. And then finally, for products which are more to do with aesthetics rather than functionality, we can improve what some people call emotional attachment, where AM can help improve the emotional attachment of a product to a user, perhaps by creating some more interesting designs. And here's some examples from Lionel Dean, who's a jeweler, and he creates some very complex shapes which actually would be very difficult to produce with any production process except AM. And again, the reasoning is that with these shapes, which can very often be customized to individual customers, then a higher price can be charged. So that's how we can use AM to try and introduce some more reliability and robustness into our supply chain, either by filling in temporary gaps or by trying to change our long-term use of overseas manufacturing and bring it closer to home using AM. However, now I want to cover something which is a little bit different, a little bit radical, and has only really emerged in the last few years. And it's what some people are calling point of sale or point of use, or in medical circles, point of care manufacturing, trying to minimize, or in some cases you could almost argue do away with the supply chain completely. So point of sale or point of use, well, we've seen that some AM systems can produce parts that are ready to use. So you can take them away from the AM system, and with minimal post-processing, it might just be brushing some dust away, or it might be that they have to be cured in an ultraviolet oven, and then they are ready for use by the end user. And if that's the case, then the only supply chain that you need is that your feedstock material for the AM system has to be provided, and then all the manufacturing is done as and when you need it at the point of use. So this is the idea of this type of manufacturing. And as AM becomes faster and more affordable, which is happening quite dramatically, then applications for this point of sale or point of use manufacturing will increase. At the moment, there's not so many of them. I will show you some, but I expect these to increase in the future. So one area where it has been used for quite a while actually is in medical models, where some hospitals have installed AM systems to produce Firstly, anatomical models to help surgeons plan operations, for example, but now also some implants are being made in this way as well, where they are produced in the hospital, ready for use as soon as they are produced. And these are known in the medical domain as point of care systems. And so here we see an example of it's a Singapore hospital that has introduced a number of different types of AM systems. And the idea being that as soon as the patient has been scanned and the design for the anatomical model has been developed, it can be produced in-house and available maybe the same day or perhaps the following day. Another area, which again is quite unusual area, but it's sometimes called 3D printed food. It's using AM to produce food products. And some high-end restaurants have actually installed what are called 3D food printers to print customized meals directly onto a plate. Now, this is not something we're seeing a lot of, but some high-end restaurants are finding that they can do this and they can charge some very high prices for this customized meal. And here's an example where we see the plate is just a square tile, but the actual food has been printed directly onto this plate. I think here there have been some vegetables added by hand, but the main part of the meal has been 3D printed, which is another word for additive manufacturing. And then maybe a more useful area is what people are calling spare parts on demand. Spare parts, especially those that are obsolete and can no longer be obtained off the shelf, we can produce these using AM if necessary on a one-by-one basis. And here's an example taken from an engineering magazine, which shows that these little polymer parts, some of which are like Lego bricks, can be produced using AM, even though they are no longer available off the shelf. But you can see that all the little parts, like little gear wheels and so on, these could be parts for things like broken washing machines or even old cars, where we can no longer get parts from any of our typical supply chains. So instead, we go to a company that specializes in spare part manufacturing. And what's been done for spare part manufacturing, other people are envisaging could be used for maybe what we could call consumer goods, where you go into a shop and have some parts made for you while you wait. And examples might be people are looking at shoes, for example, sports shoes. So that's another way that AM in future could perhaps dramatically change our supply chain by trying to reduce it to the absolute minimum. And then finally, in terms of what AM can do, I want to have a brief look at how AM can contribute towards sustainability through reducing our use of material, through reusing materials, or indeed recycling materials. Now, why is sustainability important within our supply chains? Well, we know that climate change is a major challenge to the whole of humanity. Many governments are under pressure to try and reduce their country's carbon emissions, perhaps because they have signed up to various agreements, as our previous speaker mentioned. Companies are therefore expected to play their part in trying to reduce carbon emissions. And also from the demand side, more customers are seeking out what they see as being greener products from greener companies. And so many companies are looking for ways to reduce their carbon footprint. AM can contribute to sustainability in several ways, and we'll see some examples of that now. So in terms of reducing material consumption, AM does this compared to conventional manufacturing, especially machining, by only using really the material that finishes up in the part. And so in the aerospace industry, for example, what's known as the buy to fly ratio have been reduced from maybe 10 to 1 down to 2 to 1, where previously we would have to take a big lump of metal, machine most of it away, and to leave the finished part. Whereas with AM, and here's an example of a sort of a compressor turbine, or sorry, compressor disc, where at the moment it looks very rough, but the material has been laid down using additive manufacturing, metal additive manufacturing, and now there will be a finishing machining operation that will remove some material, but not nearly as much as would have to be removed using conventional manufacturing. So in some cases, AM can dramatically reduce the material that is being processed, and all the energy costs that go into producing that material will also be reduced. We can reduce running costs, and this is partly to do with the efficiency that we looked at earlier, where we can produce more complex shapes with better hydrodynamics or aerodynamics. But also, when coupled with coupled with generative design techniques, AM can produce very lightweight parts. And these lightweight parts, when used in planes and cars as well, reduce the fuel consumption of those vehicles and therefore their carbon footprint. And here's an example from 3D Natives of a car brake pedal, where we see the conventional design, which was made in metal, perhaps using casting. But then we see some optimized designs which have been made with AM. And you see that the amount of material being used is much less. Therefore, the weight saving can be very great. Now, in the automotive world, this is typically only being used for high-end sports cars at the moment, whereas in the aerospace industry, it is being used for both military and domestic aircraft. And some of the weight savings that are being quoted are very high, perhaps a 60% weight saving over conventional processing. And then in terms of recycling material, most metal AM systems are very, very good at recycling. So either if you take the parts that have been previously produced, or parts that have been incorrectly produced, like scrap parts, or even just material that's come from other areas, that recycled material can be used directly in additive manufacturing. And this is because in general terms, many metals are easier to recycle than polymers, and AM can tap into that recyclability. With polymer AM, it's not so easy, but some polymer AM systems will allow previously made AM parts, or maybe even parts that have been made with injection molding, to be broken up and recycled into new feedstock material, typically for one of the extrusion AM processes. And here we see some nice parts that have been made from recycled plastic using an additive manufacturing process known as material extrusion. And so the production model that some people have in mind is that we will use parts which have been discarded from various sources, perhaps old computer casings, for example, and we will recycle these into more valuable products using additive manufacturing. Now, I've given some of the potential that additive manufacturing has and how it could help us, but of course, there are challenges. And these challenges really explain why, to a large extent, it's not being used as widely as we would like to see. So what are the product development challenges for AM? As I'd said before, it's still a relatively expensive technology, especially for metal parts. The machines that make these metal parts are incredibly expensive, typically about €500,000, and therefore the parts that come from them are also expensive. This is okay for the aerospace industry, perhaps, but even for the automotive industry, that's proving to be quite a challenge. Material selection is still rather limited compared to conventional processing. And with some systems, repeatability is proving to be an issue, where trying to produce exactly the same part on a system over and over again is not as easy, for example, as with injection molding. If we do need high accuracy or surface finishing, then we typically require some additional processing after the AM, which then gets rid of some of its advantages, for example, just-in-time manufacturing. And much more work is needed on standards and qualification, because compared to conventional processes, AM is still quite new, and the standards industry is still trying to catch up with that. There is a lot of design freedom with AM, as we've seen by some of the shapes that can be produced, but many designers do not really know how to take advantage of that. And if we do want to produce more valuable parts or more cost-efficient parts, then designers really have to come to grips with how the use of AM can be optimized. So finally then, just to draw some conclusions, AM can help with robustness and sustainability in several different ways, but the uptake at the moment is still rather limited, either to high-end metal applications, such as in aerospace, or to what we could call low-end polymer applications, where we can produce very simple parts, perhaps with not much performance requirements. And there are major challenges. There are typically higher production costs, and users will only pay for these more expensive products if they give greater value. And typically they won't pay much more. So we have to really see how we can add that value without adding cost. Quality issues are hindering progress. We're still seeing that AM does need to be improved in terms of the quality it can give, and designers need to wise up to the manufacturing possibilities. So with that, I would like to conclude and thank you for listening. And if there's any time for questions, I'd be happy to try and answer those. Thank you very much indeed.
Okay, thank you very much, Professor. Okay, thanks to Professor Ian Campbell for take your time for us and the information and knowledge which have been given to us. And this is the appreciation from us. And this is a certificate.
Thank you.
And once again, give applause to Professor Ian Campbell.
Thank you.
Okay, thank you, Professor. Hope we can meet again and have
a nice day.
Thank you.
Excellencies, distinguished guests, participants, ladies and gentlemen, we have had inspiring time together, and this session is about to come to the very end. I hope you found the presentation at this conference are informative and helpful.
Okay, the next session for attendees, please break for break and lunch at restaurant LG floor, then followed by parallel session. Parallel session will be shared in some rooms, and we have 4 topics. The first topic is system design engineering, location in this ballroom. The second topic is manufacturing system and operation research and management science at Denberg room at 4M. And the last topic is ergonomics and human factor at Chelsea room at 4M. And 4M is upstairs this ballroom. And for all Zoom participants, please stand by and turn on your camera, and don't forget to use virtual background, and don't forget to rename your Zoom name by topics code _name. The topics code is system design engineering is SDE, manufacturing system is MS, operation research is OR, ergonomics and human factor is EHF. I'm sorry.
Okay, after the parallel session, you can have your dinner at 6:30 p.m. beside this ballroom.
So we will meet again for awarding and closing ceremony at 7 p.m.